Hello, and welcome to Automat Live Coding. Today I will skip the usual introduction because this will happen anyway in a couple of minutes. Let's start with announcements. I will be taking vacation next week, so I will disappear for a month and a half. I will be back eventually, and I guess I shouldn't, but I will probably work a little bit on Automat during this vacation. Today we are going to obviously code Automat. That's the plan. We will be doing a lot of refactoring today, but in the meantime, like I said last time, we will be doing some watching of YouTube videos together. Specifically, I have one which piqued my interest sometime. It's Cracking the Code by Fleury. He has a blog where he talks about debuggers, and he's a person I've been following even before this software conference. Even before he presented at this software conference. So I'm very curious what he has to show today. I mean, what he has shown 2 weeks ago. So today we will actually start by recording a devlog. I promised we will have devlogs, so today we will record one, and then we will jump into Automat. I have performed a large refactoring over the last 2 days, so Automat is seriously broken right now. It doesn't start up. We'll have to do some debugging. Unfortunately, I finished with the mechanical debugging, so the debugging with the mechanical refactoring, so the actual debugging I have to do today, it's going to require some thinking. But then we also have some silly refactorings that are pretty mindless things. All of those things should really be done by AI agents, I think. Unfortunately, they are so bad at doing those simple changes. They like to mess unrelated code in the meantime. Anyway, so this is the plan. Let's start with the bubble menu devlog. So let me start by clicking the right button. Actually, no, stopping the music. Stopping the music, hiding the overlay. And I guess now we can start. Hello, and welcome to the next Automat devlog. Today I'm going to talk about bubble menu. A bubble menu is a new mechanism within Automat that serves as a context menu for the user. So context menus are a mechanism for stuffing extra options into somewhere into UI. You cannot fit everything on screen. Sometimes you just have to hide some of the options because they will just take too much space. They would make the design ugly and unreadable. So it's a balance, right? Most options should be visible out of the box, but sometimes it's worth to hide them. But do we have to hide them? If you look around in real world, you will see that we don't really have any context menus. If you imagine no thing around you actually works like a context menu. Maybe drawers, right? If you have a drawer, drawer is somewhat like a context menu. You open it and then you have a list of options inside. But it's something that we never really use in physical reality. Like whenever we have an object that we want to touch, that we want to do something with it, we usually use tools. So we have those separate objects around us that allow us to interact with other objects, to change them in some way. I can use the pencil to draw in my notebook, or I can use scissors to cut a page. None of those options are a context menu within the notebook. So if we follow this, let's call this tool pattern, if the user interface actually imitates physical tools, then you kind of don't need context menus. This pattern is common in graphics software. Photoshop, Paint, GIMP, right? You always have a toolbar with a list of tools. It's very intuitive. But still, we have those context menus, and there are good reasons why we would want them. If you imagine like a car mechanic, fixing a car, like turning the screw with a spanner. Usually you don't need just any spanner. There is some specific diameter, for example, of a wrench that you need to do something. So this is what context menus help with. When I grab my notebook and I want to write something in it, it would be convenient if the pen was somewhere nearby. So many notebooks allow you to do exactly that, to attach a pen to the notebook. So this is one mechanism. There is another, and you can see it, for example, when I right-click somewhere here. It is a mechanism for teaching. Like when I right-click somewhere, it shows me what options I can use and also what keyboard shortcuts I can use to do those things faster. There are tons of things that could benefit from this in physical reality. Like I showed you scissors. You can use scissors to cut paper. You can also use scissors to cut some vegetables. It's something that some cooks do, but few people know that scissors work just as well on lettuce as on paper. So our context menu should do exactly that. It should make it easier for the user to reach for the right tool, and it should be a teaching mechanism. So if somebody is new to the interface, it should be possible to discover what things can be done. What are they're called affordances in design terminology. So one of the primary objectives for us is to make this menu fast to activate. It's something that the conventional menu doesn't really excel at. Like, it's fairly good because it follows this principle called Fitts law. So if you're not familiar with Fitts law, it's again it's a theory, empirical theory, but with tons of evidence for it about how fast actions in the user interface can be performed. It says that the action is faster the bigger the click target is, and it's slower the bigger the distance to click is. It's kind of intuitive. If you have a mouse cursor and you want to move your mouse some other place, you have some accuracy. So you need to accelerate mouse, deaccelerate mouse, and you need to end at the right button. So this is what traditional context menus do. They open very closely to the mouse, so the distance is basically zero, and the options are also fairly large, like relatively. So it's very fast to activate it like that. But it's not perfect. There is a trick that allows us to make it even faster. The trick is to change the layout of the menu. So instead of showing menu of options top down, like a restaurant menu, we can show them in a circle. Because if an option is shown in a circle like that, then you can activate it not by clicking it, but just by moving your mouse far enough. And the nice property of those boundary-based activations is that they don't force you to deaccelerate your mouse. So you can just fling your mouse very quickly in some direction and it activates an option. It's incredibly fast, and the interfaces which use this technique are very fun to use, very responsive and very fun to use. There are other factors which we should take care of. When we are talking about speed, we should also take care of legibility. So when I open the menu, how quickly can I parse what is on screen? And if the menu is very fast, I'm speaking from experience, it's possible to use the menu accidentally. So to activate some options that you didn't intend to activate. And because of that, it's very important to have a good feedback. So different options should respond differently, using different sounds, different visuals, but also it's also valuable to have a good undo mechanism.
A G says.
Aye.
Wojciech Krofczyk says.
Hee-ho. It is good approach, unless there is a lot of items in this circle. List of items could be very large, and you could find an item by searching for first letter.
Yeah, there are some interesting tools which follow this idea. I'm not sure if I can remember the name, but okay, after I record the devlog, we can go back to this. Okay, so going back to this. So let's look at an example of how a menu designed like that can look like. So this is a design. This is a predecessor of Automat. It's a mobile environment for automating smartphones. If I play it, you can see how menu works in this system. It's a circular menu where options are arranged in a circle. They have some indicators about what will happen if we activate them, and pausing on any single options shows a help bubble that tells you what given option does. And this help bubble actually, it's not super visible here, but phones are multi-touch. So this environment actually uses that. So if you're holding with one finger the screen, so that it shows the bubble menu, you can use the other finger to actually click and ask for more help. So multi-touch is a nice thing. It complicates a lot of things, but many things are also easier because of multi-touch. So this is design. In Automat, we are a little bit more skeuomorphic. So we are trying to use more natural metaphors in the user interface. The menu is not just a piece of slightly rounded rectangles and black and white icons. We're actually trying to make the interface look like what it does. Look like the thing that it imitates. So when looking for the right metaphor for this, my favorite example were flowers. Flowers are something that we see all around us. They have this nice circular shape, and they usually have petals that can be picked. And the petals, picking a petal is kind of like cutting a branch of a plant. They also have this fun property that they will grow when you cut them. So it opens up so many possibilities for nice visualization of this. This sort of visualization would be very, very tricky though. Good animation of plants is hard. In Automat, we have a little bit of that here, but those plants are not very natural. They are following pre-recorded paths. So this is not the direction we went in Automat. So our final design actually resembles, it's not big, it's not such a big reveal because you probably know this from the title of this dialogue. Our bubble menu is a bubble. So the advantage of this bubble metaphor, I will zoom in so we can see better, is that first of all, it's pretty, and being pretty is important in user interface. Second of all, it's something that everybody had encountered pretty much in their life. Bubbles are naturally round, and they have this, the nicest thing about bubbles is that they have this natural boundary that pops when you touch it. So it is actually good at signaling that touching the edge will do something. If you are touching edge of a bubble with an arrow, the bubble is going to pop, right? makes sense. So those are all nice advantages. The last one is that bubbles are incredibly easy to animate. The mathematics of bubble reflection are pretty well described. It's called, I think, thin film interference. Lots of articles and nice shader examples you can see. So this is how many works in Automat. The way it works right now is not how it will look eventually. There are some other aspects that we would like to tie in. So one thing is that the options should appear at consistent positions so that it's possible to create muscle memory. When I was working with design, this muscle memory was super valuable. It was possible to operate on multiple objects by just very quick movements, like you move finger right down and upper right, and you memorize this movement in your muscle memory. So when you want to do something in the future, you just do, and it's activated. So consistent option positions are very important. They are still not there in Automat, but they will eventually. Then we have animations. If you took a closer look, you probably saw that animations they use this zooming in approach where the bubble starts small and grows. This is not how bubbles appear in real life, because if you played with these with those toys that make bubbles, they usually create a film of soapy water, and then when you blow on this film, it slowly creates a convex surface and eventually it detaches, forming a round bubble. The thing is, the round bubble that is formed is usually smaller than it depends how strong you blow, but the bubble is typically smaller than the surface that it was created from. So typically, like the bubbles in Automat, when they appear, they should not appear as growing from small to large, but actually as shrinking from a large but flat film of soap into a circular, slightly smaller bubble. Lastly, there is, there is also the wobble aspect. When you create a bubble by blowing air, the bubble doesn't start as a perfect sphere. It's usually slightly stretched and it oscillates in a fun way. The surface tension of water tries to optimize the shape of the bubble. So this wobble is a nice aspect of this. Then there is the bubble disappearance. The bubble disappears in Automat instantly right now, but in reality, when you pop a bubble, it explodes into a mist of tiny water droplets. It's very subtle. You will only see it if you look at bubbles at slow motion videos, but once you see this, you will realize that this effect is there and it's kind of important for the bubble to feel right. Then the bubbles in Automat still don't have an integrated help system. So this is something that has to come. And lastly, Automat is about automation. So it is important to design the bubble interactions in such a way that when you create a bubble, you can not only execute this action once, but you can form a repeatable machine that will perform this action repeatedly for you. And this is another aspect that we need to take care of, but probably more about this later. There is one more that I will mention. It's that hovering over an object, even before we open the bubble menu, at this point we should already be using the mouse position to signal to the user what actions are available. So I think there is something that we can do with mouse position that will make the system even more readable. maybe it's a topic for another devlog. Okay, so those were bubbles in Automat. I guess on the next devlog we'll talk about probably about mouse traces. Anyway. Okay, so thanks for watching this devlog and see you next time. Bye. Okay, and that was the devlog for today. This is something I will have to cut offline. I hate cutting. Let me quickly see how much I've recorded. Typically I tend to ramble, so it's probably way too long. 17 minutes, oh god. Okay, we'll do it. Okay, we'll move to the next point, our plan, which is this. Actually, I will start by debugging Automat, because watching a video is doable for me, but only when I'm doing like really simple refactorings. So right now I actually am in the middle of debugging a bigger change. By the way, bigger change I will show you. I have changed 82 files, and the change is very non-trivial. So it's super messed up right now. Lots of changes all over the place. Things basically stopped working. I have to now step through Automat and fix all of the places which I broke recently. Oh, Wojtek, you mentioned about these alphabetical options. There was a cool app that actually exploited this idea. It was called Dasher. It's called Dasher Keyboard. Yeah, this is how it looks. It's an accessibility device actually, but it uses something very similar. It has those options sorted alphabetically on the right edge of the screen, and by moving your mouse in this rectangle, you can select the right option. It is a little bit... This is actually a little bit slow because it uses a gamepad sort of like mechanic for moving the pointer. But I think the same Dasher idea could actually be... I think it's possible to make Dasher work in absolute coordinates, so that if you have a rectangle, you basically move your pointer into this rectangle and move it left to right, and this movement activates an option very, very fast. And something similar could probably work in a circular menu. Yeah. An interesting idea. Maybe we'll prototype this, because that sounds fun. Like, it's not great for discoverability, because if you have an alphabetical list, you don't really see all of the options, so it's hard to browse them. But I still think it's going to be interesting. Yeah, so maybe on one of the future streams we'll play with this idea, trying to design a menu based on alphabetical sorting. Because the problem that you mentioned is actually a big issue. The number of options. The menu has to be... is kind of constrained. There is another law called Hicks law, slow. It says that in a similar way to fit slow, in a similar way to distance, the higher the number of options, the slower it is for the user to pick one of the options from a menu. So cleverly grouping options into categories is kind of important. Sorting them alphabetically, probably yes. Kick slow is really about mental load, not about sorting. But still, it's a fun idea to experiment with. Maybe I should pin this. Size this. Okay. Now we have a persistent stream agenda on screen. Shouldn't even be that problematic. I almost don't use this region. Oh, I have everything I need. Okay, I was at this point and I noticed an issue about this object widget. I think I probably fixed the last issue. This perfect day for programming because it's raining. When the sun is shining, I always have regrets that I'm coding. Oh wow, it works. I mean, almost. Nice. Super nice. We have some more bugs now. When I run Automat, I think the initial window that will show, now it looks good. Okay, apparently there was just one bug. I was expecting I will have like hours of bug fixing before we get to do anything with it. Actually, yeah, we had an issue here. It didn't render the widgets properly. What was that about? When I unzoom, it works. See, there is something weird happening with this widget right now. I don't get hover animations. That's the first suspicious bit. hover doesn't seem to work. More debugging. So picking and dropping an object caused a crash. And there was something weird with lack of hover animations. So the stuff that I did off stream was that I had this massive task about splitting each object, which is simultaneously a widget, into separate classes. And I found the trick to kind of make it work without this split. Sort of. But now, because of this trick, there are tons of bugs. Okay, we are stopped, I think, at a breakpoint, right? Yeah. It's not relevant. Let's continue. Okay, so picking an object and dropping it caused the problem. Okay. Okay, widget is null. It should never be null here. Interesting. So I'm creating a copy of this path. And some of those widgets are gone. First of all, instead of making a copy, I should do a move to avoid the copy altogether. Blah blah blah. Uninitialized copy. Sure. Okay, so we are activating a copy constructor. This is our copy constructor. I will use the default constructor and if other widgets, then I will link. That will fix it in this place. There's another place where I think this should be fixed, and it's here. And this will be an issue. There is no point to move anything here. But whatever. Let's try this again and see if picking and dropping objects still causes a crash. And we are waiting, so why not watch this?
All right, good morning, everybody. I hope we all had a great time drinking yesterday, hanging out, the nice dinner. For the future dinners, alcohol is not included. We'll run out of money. Today, our first speaker is Ryan. You know, we all know Ryan strikes fear in his enemies because he's so good at what he does. And now, as you remember from yesterday, he's learned to ride the moose.
That's true.
So truly now, he will be completely undefeated. Everybody, Ryan Fleury.
Thank you. All right. Well, thank you, Sam. That was a great introduction. It was not a real moose, by the way. It was fake for those watching online. So, hi, everyone. Thanks for being here and coming to listen. Thank you to Sam, Sander, and Charlie for organizing this. This has been absolutely amazing, like the best energy of any conference I've been to by far. So thank you guys so much. Yes, clap for them. And I'm honored to be here because there's so many people you've brought that I really respect. So it's like dream come true to be here and speak alongside them. So for those who have not yet met, my name is Ryan Fleury. I work on the RAD debugger, which is the project originally started by Rad Game Tools. You may have heard of it from like 2013 or whatever when it started, when I was like 15 or something. It's gone through some successive teams. But Rad Game Tools is now part of Epic Games. If it needs to be said, though, I'm not here to represent them. I'm here on my own behalf. So while working on the RAD debugger, I've tried to prioritize something that I've always felt is missing from programming tooling, which is good visual feedback. So having open visibility into a system. I've always felt that computers are very opaque.
Yes,
coming from game
just
development,
fixing the opaqueness is it could be said that fixing the opaqueness of computers is what's going to fix the technology. Like, very few people can access technology because it's esoteric. It uses you to be familiar with tons of formalisms that are taught in a priest-like way at academia. It requires a lot of time and dedication, and just making it easier, making it transparent, visible, is going to help a lot. Very true.
It's really easy to learn when you are always debugging things, that it's very useful. We saw in Dennis's talk that it's like if you're looking at timestamps, it's totally different experience than looking at a profile, at a flame graph, right? It's a completely different experience. And game developers, you always are visualizing things. You're always trying to get a different view into your data to make something clear. And we use those visualization tools to create better software more efficiently, which is why we're all here, right? So, in other words, it's useful when cracking the code. I did the title thing, so. So there are many talks or resources on debuggers, but my impression is that not many of them focus on this visualization problem, even though I would claim it's perhaps the most important problem that a debugger needs to solve is quick, good visualization, flexible visualization into your data. So I'm going to present all the work that I've done on that problem to you all today. Now, if you aren't familiar with debuggers, or if you don't know what I mean by visualization using a debugger, I have some videos of the RAD debugger that I'd like to share to set the stage for everything I'm going to talk about. So, first thing, if I've got my little game project, shameless plug. It's not really special yet, but if I've got this program, I can do things in the program. If I want to run that from within the debugger, in the case of RAD debugger, I can do raddbg, same command line. Opens up the debugger. I can either launch the program from, with the debugger attached. I can also step into the program. These are all very common debugger features, right? I can step through the code.
Could literally use this RAD debugger
So now
now.
I'm stepping over lines of source.
Does it work on Linux? Let's see. Unfortunately, no Linux. I mean, we will have an opportunity to use it when we switch to Windows.
Code. I can evaluate things if I hover them. So if I can put a variable into the watch window here. So in this case, it's the global shared. And if I expand that, you can see as I step through the code, you see things change live. It's very, very common debugger.
Nice choice of fonts, because they are all condensed, and it makes it possible to, on a relatively small screen, open 3 columns. So and each of the columns actually has tables inside.
Features, really. Debuggers also tend to have features to navigate to different parts of the code. So I can go to some function and place a breakpoint, say stop at this line of source code, and so on, right? That's pretty basic debugger stuff. That's this is what it looks like to use one, right? Google Slides is weird with videos. Okay, so let's say I've got a crash in my game. I'm hooked up to my game, I hit F5, or I press the green arrow, F5's hotkey for that. The debugger will catch that, it'll show me where that is. I can dig into things like the call stack. I can evaluate things still. I can see why some bug is happening, right? I can sort of get visibility into the system when something goes wrong. I can go back frames in the call stack, stuff like this. Okay. So, let's say in my game, for example, the player can hit something. So if I go ahead and spawn a little jelly entity here, I can walk up as the player and punch it. If I wanted to specifically stop when that punching code path is hitting, I can go ahead and find wherever I wrote the code, put a breakpoint there, and then I can just wait for that event to happen, right? Wait for that code path to be executed. You stop, and at that point I can inspect the state, right? Most, very common debugger stuff, but I know a lot of people don't. They claim they don't use debuggers, so I figured I would just show it. You can also add conditions to a breakpoint. You can say only stop if this condition is true. So in this case, I'm checking if it's specifically the player's right hand from our perspective, right? So yeah, there you go. So what exactly do I mean by visualization? As I kind of covered already, a basic version of this is the watch window, right? You can evaluate an expression and see things change. Another example would be memory view. There's just another very common visualization technique in a debugger. You just want to see a grid of bytes in sort of a hex editor style view. And then many of the same things apply, right? As I step through the program, I can see particular bytes change. So here I'm evaluating the string variable. And then I think I go to the memory for it, and if I step, you'll see it changes, etc. So basic, very common debugger visualization features, but this is the subject. Now, again, just a couple basic examples. We'll get into more later. But I find this particular problem important because for me, while learning programming, things would often feel like this. Now, for those who don't know what this is, I didn't either. This is the origin of the term black box. It's a flight log recording device, and yes, I thought it would have been black as well. But no, it's orange for whatever reason. But in programming, we've abstracted the term. As we know, programs can be understood as a transform from A to B, right? Some input data in some format A to some output data in format B. We use the term black box when we don't know anything about why something happens between A and B. We don't know why it produces B, we don't know how it's happening. We hit a button, we run a program, and something happens, out pops a B. You know, maybe you hope. If it works, great, and if it doesn't, God help us, right? Another way of looking at this is that the arrow in the middle, the code, is showing very few signs of life. Your program is doing something maybe undesirable, and you don't know why. There's very little information coming out of the system. Meanwhile, you just want your program to work. As I see it, the challenge here is that computers are inherently opaque to us. They're doing billions and billions of things per second, and so there's actually an enormous amount of information you might actually imagine needing in order to understand what's happening. So it's always a game of understanding how to narrow down to the subset of information you actually care about and presenting it in a way that makes sense. Now, one of the first ways we learn to extract information from a program is through textual logging or print debugging. Your program does whatever it was going to do, and then in addition to whatever it was going to do, like the thing you actually wanted it to do, it produces a parallel output, which is just like the textual log of what happens. They come from print statements you annotate your program with. Now you'll see some people make the argument that this is all they need. And what I'm about to say might surprise you, but in one sense, they're right. But there are two problems with their argument. One problem we can solve while keeping print debugging, one problem we cannot. Problem number one, text often sucks. It's often insufficient, right? You can't understand what it's actually encoding. Let's go ahead and do an example. Let's say we have some image format decoding, decoding code, and we want to test it, and we expect to get, something like this image, right? Can anyone tell me where the bad pixels are after I've loaded the image? I've done the printf debugging. Okay. If you're looking at this, it's like, oh, like what's that? What are those fuchsia pixels in the corner, right? Like what is that about? So you can instantly see the problem when it's presented to you in a different way. Similarly, you have some 3D geometry data, and I give you this. You're not going to be very quick to like pick out where the broken vertex is, right? But if I show you this, it's like, wow, something's really off there, right? It's like you've got this cube structure, and then what's that vertex doing over there? Like, what is that about, So there are numerous examples like this. Text is sometimes exactly what you want. It's oftentimes not. But this is the problem I suggested we could.
The biggest advantage of text is not really a kind of choice between debuggers or printf, because printf debugging does something that debuggers do not, and this is slicing the program across time. If you use a debugger, it shows you a point-in-time snapshot of the current state of the program. But sometimes you want to see how the program evolves over time. And for this is where people use printf debugging. Debuggers, they could have tools, better tools to visualize stuff over time. And they just don't. For some reason, they choose not to.
Could solve. So even when text is not enough, you didn't necessarily need your log to just produce text. You didn't just need the print statement, right? Or maybe that's not the only thing you could have done. So this is an example of one solution to that problem. This is GraphViz, or a screenshot from the GraphViz visualizer. In this case, your program still outputs text, but it outputs text in a structured format that can be parsed by a visualizer program. Present your data like a graph like this, right? Another example, this is Mustache, made by Casey, who you all heard from yesterday, specifically designed to debug image and video compression software. So this system works pretty much the same way as print debugging, but it's structured, right? It's not just textual data. It's not presented as just textual data. In the same vein, there's this program called RenderDoc. Anyone who's done any amount of GPU programming probably knows that without this program, your life was probably pretty bad. Everyone has their story of you set up all this boilerplate, OpenGL, Vulkan code, whatever it is. You run your program, you're really excited, and there's a black screen. It's just what's going on, right? RenderDoc's extremely useful, so it sort of logs all the API calls you get, and it captures state, it hooks those APIs, and it captures that state, and presents it in this form. It knows the before and after states of every GPU resource that you touch when you make those API calls, right? Or caused by the work implied by those API calls. So it's another example, it's yet another structure of a structured, non-textual log. So just to be clear, I'm not saying that logging is wrong or not useful or can't be better than just helpless print debugging, but there's another problem. Problem number 2 is time, and thus money and sanity. The second major problem with log debugging is that it often requires modifications of the program that you're digging into. So let's set aside the cases where you can't actually do that, right? You're not doing any reverse engineering, you're not doing any of that. You can control your program, you can modify the program. There's still a problem with requiring that in order to get at very simple information. Let's walk through the series of steps you might go through when using logs in order to debug a black box. So first, you're presumably writing some code for some actual task you have. Number 2, you build, right? You wait for your build to complete. You run, create whatever state you wanted to be in to observe the code that you wrote, and then you...
Let me do a quick break here and get some tea. We will be right back.
Pavone 1960 says,
I'm from Morocco and want to build a student website. I need $360 for hosting ads and plan to do manual work for a month to fund it. But I'm unsure about revenue from Google Ads. Should I start now or keep learning until I get a programming job?
Okay, let's resume the video.
Right, you observe the log.
Bert.
And then a very common outcome of this process is you realize info you didn't
Hey.
you needed isn't logged. You add new logging code.
Let me read the chat. I did a little bit of ads on AdWords, but my results were very mixed. So in the past, I started a company, I wrote a piece of software and I was advertising this on AdWords. And the conversions were very poor. Like for me, like in the end, it turned out that it wasn't just worth it. It's a hard problem. I'm not an expert in this in terms of using the advertising tools well. I think the traditional advertising right now is slowly fading away. I think it's slowly being replaced by advertising through social media, those viral posts or sponsored posts, this kind of stuff, instead of Google Ads. Maybe I'm wrong. Again, I'm not an expert. Probably the worst person to ask about this stuff.
Code, and you go back up to the build step and you run an observe.
I mean, worst because I actually lost a lot of money trying to advertise on Facebook and Google AdWords. Yeah, for me it was just a big miss.
Same thing with profiling, same thing with any form of
Thank you.
like this, right? Because it's explicitly wired into the program's code, right? In other words, let's say you're missing some expression X from the log, where X could be anything you might evaluate within a log or print statement. After you discover this, the new information you have that you could enter into the system is simply X. In a very basic, more ideal user flow, you would just have to write that. You just have to say X. X is what I'm looking for, right? Instead, you have to find a spot in your code, write the extra printing or logging code, and that's like the best case, right? We don't know what it's going to look like. You build, you run and recreate whatever state you wanted to be in, and then you browse the log again. And needless to say, the huge problem with this is roughly instant for the user. This is often frustratingly long. So even in a small, well-organized code base that builds very quickly, that's optimized for very good development times, this will take many extra seconds. Furthermore, if a code base isn't prepared to recreate state very easily, which it very often is, not prepared to do that, it'll be much worse. And lastly, browsing the log itself can often be quite slow. And the reason why is that it's a fire hose of information, right? You have so much information pouring into you, and you're just like looking for, sometimes the log is useful information, right? Sometimes you want to see it over time, but if you're trying to zoom in and really narrow in on one particular thing, you have a whole window of information that you have to look through. So, I think of this problem as being related to information flow.
Wantoninity 8 says,
Sup, man? How is going? How is life?
On the left there.
Hey,
Good diagram. Pass down your information as inputs, computer returns it back out as outputs, right? So we repeat this cycle of information flow in order to sort of refine our data over time. It's this constant back and forth with the computer. You start with some very unrefined state, or no state at all, and then you progressively refine it. You build towards whatever you're trying to build towards. For programmers, the data we're working on is code. So if we zoom into one of those like little blob shapes, we've got A to B prime and then A to B double prime. That's what we're refining. The information flow cycle is sort of what pushes this forward, right? We see the outputs from one state, we produce information that encodes a new state, and so on and so forth. So we can think of this refinement process as like a repeating cycle across time. And now maybe this is all just like a little abstract, and I get it. But the reason I frame it this way is to associate certain problems on computers, like with programming or debugging, or understanding anything with certain undesirable properties of this sort of like wave pattern that you end up seeing. For instance, programming can feel very frustrating, or more opaque or more difficult to understand when this cycle has a much longer frequency. If the flow of information is blocked on something, let's just use compile times as an example, you tweak something, you accidentally touch a C++ header file, you're in like some major nightmare C++ code base, you hit build and you're like, great, I can't wait to test this new like jump speed or whatever, and it's like 10 minutes, just gone. That's
Happens whenever you touch a header.
an example of like deterioration of this information flow, the quality of this information flow, just due to this frequency expanding. So this is less efficient, it's less effective, it's not good. Furthermore, the information flow doesn't only have a frequency, but a bandwidth as well. Now, to be fair, I probably could have drawn that as like the amplitude, but I just wanted to make it like thick versus thin for whatever reason. I don't know, it's all abstract, but you get the point. If you're waiting a long time for some information to come back, it's better if you get a lot of information. If you get very little information and you're waiting a long time for it, it's like almost completely useless. So the goal is to maximize frequency and maximize useful bandwidth. So let's take a look at logging from this perspective. Logging does obviously have the ability to provide useful information. It can dramatically improve the bandwidth of information output from the computer back to you, but it can require many slow iterations to refine for some debugging case. And again, there's a universe of information you could be looking at. You can't log all of it. And it can also slow down the execution of the program itself. So you get a little bit thicker bandwidth, but you decrease the frequency a bit. So hopefully I've been convincing enough to show that while logs can be good and while this is a completely valid technique, it can be less efficient than what you might imagine is the ideal case. That's where a debugger comes into play. So I'll start by saying that I often see debuggers misunderstood. If I could have gone back in time, if I was in charge, I wouldn't have called them that probably. I mean, I understand it's like the physical bug in the machine, everyone knows the story, but it might illuminate them a little bit today, like modern debuggers, if you think about them as just a program analyzer, so giving you a window into your program. Really, it's just giving you information extraction tools. In any case, a debugger allows us to analyze a program at runtime without modifying it. You can use structural information about the program stored in debug info to get like read eval print loop style features at the limit. And therefore, you shortcut the code modification process altogether. You completely avoid the tool chain. Importantly, a debugger allows us to avoid that second problem of modification time. How long does it take for me to get some new information out of the system, all right? So the reason I've been so focused on debugger visualization and the reason why I would argue it's important, and hopefully it's been convincing and justifies this talk. First, the visualizations don't need to be textual, and second, they don't need to require this build, run, recreate state, observe loop. So in order to be useful, a debugger has to meet that mandate. It needs to provide a variety of visualizations, not just textual ones, and it needs to be able to do it quickly. If it can't provide a variety, then it forces the programmer to go back to custom logging tools, and if it can't do it quickly, it's faster anyways for the programmer to go back to the program and just write their own custom visualizer, right? So if it can't do both of those things, then the utility of a debugger dramatically drops. So let's look at how this will work. I'll start with a brief introduction to the basics of how debuggers work with your programs at all, and then we'll build up from there. First, let's consider how your program is executing on a modern operating system. And note that like the terminology I use, it differs across environments or platforms, but you can find analogs of everything. It's all, you'll find the matching terms if you look. So when you start your program, you've got your executables file on disk. There's a bunch of DLL files on disk. Those can be referred to as executable images. When you launch your process, the kernel's loader is actually going to take those images and it produces modules. Modules aren't exactly the same as the executable images, but you can think of modules as sort of the loaded equivalent into your address space.
Yeah, image. It's an important thing, but the terminology is funny here. It's called image because it comes from the virtual machine image. Like if you create an image of virtual memory and you dump it into a file, it has those sections of memory which have some data filled in them and gaps between them. So this is why this is the meaning of the word image that he's using here. Every executable is actually an image. It contains a mapping of memory. It says that, hey, at this address in memory, there is going to be this data. At this address, this data, and so on. And it also attaches names to different sections of memory and says how they can be assembled together. So this is why ELF is called executable image format, because it's an image of computer memory.
Base of those executable images.
Executable images.
The process also includes a page table to map from, it's got a virtual address space, it maps from virtual addresses to physical addresses. And your process also contains one or more threads that are executing just pieces of code, right? And each one includes things like a register file.
Modules are a Windows-specific thing, though. They are not universal. It's just how Windows organizes code.
Kernel scheduler then is like, I've got all these threads, I'll start putting them onto these cores, we'll schedule them, get them going, and then your program is executing. Right? So a debugger is just a program, and so when it executes, it's just another process, one which the kernel records as being attached to... got it, thanks. It's just another process, but the kernel is just recording the debugger as being attached to the debug gate. It's just a state in the kernel. When a debugger is attached to another process, which I refer to as the debugee, I don't know if anyone else does that, but it's kind of, I don't know. Hopefully it's clear. Hopefully I don't fumble it. But point being, when you're attached as the debugger, the kernel will report to the debugger debug events. You get sort of a series of debug events. Sometimes the building blocks that the kernel provides are lower than this, but in principle, this is sort of how you can conceptualize it. And these debug events include things like, okay, a thread has been created, a module has been loaded, etc. Or, I should say, this one's important, or an exception has been hit, right? Like a hardware exception.
On Linux, it's not like that. On Linux, this debugging workflow uses signals and ptrace syscall. So when a debugger attaches to a debuggy, it calls ptrace and it blocks itself. So it waits for the tracey to do something. And when tracey does something that was configured, debuggy, following this terminology, does something that was configured by the debugger as interesting, the operating system is going to pause the tracey and resume debugger. The fun thing is that those two processes, debugger and debuggy, they often kind of share a single thread, because whenever debuggy stops, debugger starts. Whenever debugger stops, debuggy starts. So it goes in a circle. I think this is this is probably this circle that I'm talking about.
So the debugger process control, like the piece of the debugger that's doing process control.
The only way for debugger to do work while debuggy is doing work is to actually spawn extra threads to do stuff in the background.
And the debuggy are in kind of one of two states you can think of it. Either the debugger's process control is running and the debuggy is paused, or the debugger process control is paused and the debuggy is running. So kind of a ping pong between these two states is happening. And this means that execution between a debugger and debugee can sort of be, you can think of it as interleaved across time. Like, it's mutually exclusive. Only one is really doing things at a time. This allows the debugger to sort of interleave its execution with the debugee in a variety of ways. So this is how the runtime code modification actually works. It's that the debugger has the opportunity to sort of mutate the debugee live before it continues, so you can change how it's actually executing. That's how it avoids the whole build step altogether. Now the granularity here is somewhat subtle, and it varies by platform. So, for example, while the debugee is executing, the debugger could still be doing UI. Like, it's not necessarily exactly that the entire debugger is stopped while the debugger is running. Now on Windows, it tends to look...
Yeah, he's pausing there because there's a lot of nuance here. It's sometimes the operating system will try very hard to pause debugger, so it's hard for debugger to do stuff in the background.
A lot like this because it's explicitly like wait for a debug event API. So in that case, it's like your thread is literally sleeping here. So it looks a lot like this, but hopefully that's clear enough. So this interleaved execution, like I said, the debugger can do a bunch of things like read registers, write registers, read debug events or obtain debug events, read memory, write memory, and so on. And then, from the, well, that covers all of it, right? Read and write is, reading is the blue, and then writing is the orange, right? So, we know that a debugger can read registers in memory, which is really the main building block for like extracting information out of a process, right? You can read memory, right? And so like all we need is to like ask the user for an address, ask them for a size, and then we just show them the bytes, and then we're done, right? Visualization, the end. Obviously not. As the user, you don't want to ask about address. What did I write? 0x1F43B5C00B0. You wanted to ask about X. And ideally, the system which allows you to ask about X is flexible enough such that X is a large set of expressions. It could be many things you could ask about your program. Debuggers know how to evaluate something like X through an expression evaluation system. And this is where all the visualization stuff starts kind of piecing together. So let's dig into that.
This is actually very interesting because there are many alternative parallel ways to visualize stuff. And how do you choose one? Like, there is probably no built-in kind of instructions into a program. Like, if you look at an executable, it probably doesn't have too much symbol information that would allow you to discover the types and choose how to visualize them. So this is interesting to me, how to do this part.
Evaluating expressions is just a compiler. It's just a compiler problem, normal compiler problem. We know how to solve those. If we have some textual expression, like entity.targets at 5, the first step we can use to understand that expression is to parse it into a structured representation. Now, Sam has some opinions that will invalidate what I say, maybe, but the traditional pipeline is like, okay, first you're going to parse it into some sort of abstract syntax tree structure. In this case, not surprising, square brackets at the top, 5 on the right, dot operator on the left, entity dot targets for the children of the dot operator. From there, you can evaluate types for the abstract syntax tree. You can type check it, you can interpret it, or you can produce any intermediate representation that you need. You can lower down to bytecode. You could even lower down to native code. In this particular case, if we boil down to like a simple sort of stack machine, like intermediate representation bytecode like format, not that surprising. Push the address of entity, add the offset of targets, add 5 times the element size of whatever this array is, and then you pop, and that's your address of entity.targets at 5. And then, obviously, to compute the value of something, you just read from whatever that address is, because the debugger can do that, and then you've got your value. So the full pipeline might look something like this, and we can call that an evaluation. So you start with the text, you get an abstract syntax tree, you get an intermediate representation, a type pops out, and you get a value finally at the end. But how does our compiler know what the address of entity is? Like, what was that? And how do our compiler really wants to talk about the same things that the actual program compiler talked about. Like the thing you're interacting with when you write the code, the debugger wanted to talk about that stuff too. And we can do that with debug info, which is provided to us by the compiler and linker. Whoops. Okay. So debug info contains a ton of stuff. Like there's just tons of stuff in there. I'm not going to cover all of it. But you can think of it as sort of a serialization of what the compiler and linker did to turn your high-level source code into your final, executable images, right? So it's sort of a recording of like what work happened, if that makes sense. So one thing that debug info has, which I don't cover here because it's not exactly relevant to this talk, is line information, which will take it takes like ranges of executable code inside of your executable image, and it maps it to some source location. So that's like one thing it's used to implement things like stepping. Not going to get into that here, but that's in debug info too. So these are all the parts that I would consider relevant for like evaluation, the basics of an evaluation system, right? So you've got types, globals, thread locals, procedures, location info, scopes, and locals. All of this information about all of these is inside debug info. The thing about debug info, very cross-referential. So globals all point to their type information. So a global variable obviously has a type, global gets a type, thread locals get a type, procedures get a type, local variables obviously get a type. Locals refer to their location info, hint for the address of entity thing, we'll get there. And scopes refer to the local variables that they contain, and the procedures refer to the scopes that are sort of nested under them. Zoom into types. Types take
it looks very complex.
Graph. So let's say I've got some type, int32, 4 bytes. Everyone knows what an int32 is here, I would imagine. The type information records that as sort of a basic type. It can encode like the name of it, and then its size, and then probably like it's just got a fixed code for this in pretty much every case. Types can also act as type operators on some other type. So you've got a type, it can point to another type and say I'm an operator on that type. So here, I've got this 16 array type, and it points at the int32 type, and if I point at the 16 array node, that's a 16 array of int32s. If I've got a pointer type pointing to the int32, if I point at that, if I say like that type, that's going to be an int32 pointer. Double pointer, 32 array of double pointer. Type information, maybe unsurprisingly, also covers user-defined types like structures. If I've got two structures here, and we've got entity, vec3, entity's got position, velocity, vec3, x, y, and z. Then there's some base type float32. Not that surprising, hopefully. Position points at vec3, velocity points at vec3, x, y, and z point to float32. That's how that'd be laid out. So, like I said, debug info has data about scopes in your program. So let's say I've got this procedure update. We've got some local variable, entity, pointer, entities, and we've got two loops. We've got some IDX variable. That's how I shorten index. I don't know how many people do that, but so index, and then we've got maybe we're looping over the entities or what.
Inversey says,
Hey, how's it going?
You've got a procedure record for
Quite well, quite well.
procedure. It points at a scope tree underneath which you also have local variables. So you've got at the root scope, you've got the entities variable. At the two subscopes, you've got two different index variables, and each one of the variables points at their type info. So you've got index, maybe points to int64. Entities points to a pointer, which points to an entity type. That's how the type might show up. A variable like index not only refers to an int64, might also refer to...
What's this for that you're watching?
And this location info is how our debugger's expression compiler can actually understand where certain variables live. So if our variable index within some...
So this is a guy, I was following his blog because he was writing about, actually I don't remember what, probably about his debugger. And that was helpful for Automat when Automat was getting its own debuggery features. We have when we have some machine code that runs. Show this out. Didn't crash. Yeah. When Automat runs, we need to extract register values from a thread which maintains those register values. So some parts of Automat need to use some debugger techniques to work like that and to achieve real-time modifiability. So if I have a sequence of instructions, when I want to change them in real time, that also requires some debugger cooperation. And I'm actually surprised nothing crashed when I was showing this, because right now this whole thing is in a state of... It's in progress. It's a little bit broken. Like the parrot doesn't want to wake up, the buttons do not highlight. All sorts of weird error messages. That I will have to fix in a moment. Yeah, so I'm watching this talk. I'm actually very interested in how he decided how to pick different visualizations, because I already like that he already mentioned that text is not everything, so debuggers should not limit themselves to text. I love it. So I wonder, how does he visualize stuff then graphically, which he hinted at?
Some scope is that like the value of the stack pointer minus 64 bytes. Then the location info is...
And the stuff that he's describing right now is probably the key to this. So he's describing how types are recorded in Windows debug files, which is very platform specific and probably doesn't really cover any sort of visual presentation techniques.
What's going to tell us that? It's going to encode that somehow. It might also tell us that a variable lives inside of a register, or the value of a variable is like, it could be arbitrarily complicated, really, that it can be computed somehow. But those cases tend to show up in optimized builds, right? You're not always going to have complicated cases like that. Global variables and thread locals tend to have much simpler location info. They tend to be like fixed offset, like address offsets into, in the case of globals, like a module or something. So with all of those pieces, we can sort of put together a compiler in the debugger which evaluates expressions.
I've never made a debugger, but interesting how they work
The
nonetheless.
value of an expression, I'll unpack how we can begin to
They are
visualize it.
kind of like ultimate hacks, because I mean you can use debugger to debug, but the core value of a debugger comes from the fact that it can modify memory of other processes. It's not always for the purpose of debugging.
So the most basic form of visualization that we can do for an evaluation is turn its value into a string, right? Just turn it into text. So, for example, you've got some entity expression. You want to turn it into a string like this. You've got, left curly brace, and then you print out all the members recursively, and so on. So what this code path does is sort of inherently dependent on the type information of some evaluation. So you can first note that we've got a set of like known simple cases, right? We know how to print an integer, we know how to print a floating point, we know how to print, well, okay, strings are complicated, but we know how to print those two, right? It's like an integer.
This is off topic to the talk, but do you know what neovim is?
Mm-hmm.
With floating point, also you can change the radix, but we know how to print these two things. With strings, it's relatively basic, but it's not as trivial as those first two cases, because strings, they're not normally encoded as, or they're normally encoded as like a pointer or an array of characters in the case of like C types. Obviously, there's formal types in the languages, but in terms of debug info, there's no string, like there's no formal string type in the debug info, obviously, because debug info evolves around sort of the C tool chain.
Are you using neovim?
String types in other languages, they're not buried that deep in the ecosystem.
No.
So if it's a pointer to a character type, it's a pretty safe bet.
More of an Emacs guy.
To a U8,
But I'm actually not using any of them to edit code. I used to use Emacs a little bit for coding, but it always requires a very lengthy setup. I guess it's the same with NeoVim. Eventually I switched to VS Code, or like right now I'm using Cursor, but really it's just VS Code. VS Code with a different logo.
Like maybe a string, like who knows for sure, probably, maybe not, not really clear, but you can try it, and then if it doesn't produce any, seemingly readable text, maybe don't use it.
In VS Code, many things are just configured out of the box. This is the biggest value I'm getting out of this. I don't have to manually set up, the compile commands JSON for every project that I'm compiling. It's able to just figure it out for me. Typically works perfectly.
Yeah, it's quite easy to fall into config hell. Do you at least use Vimmotions or Emacs alternative?
Emacs uses just regular, so Emacs uses mostly arrows, except a couple very basic shortcuts like Ctrl-A, Ctrl-E. If you used any sort of terminal, then you're familiar with Ctrl-A and Ctrl-E, because they are used to jump to the start and end of the line. And all sorts of shortcuts that Emacs uses are pretty standard on terminals, like swapping the words or swapping individual letters. So Emacs uses more like terminal commands. I mean, Emacs uses the same keyboard shortcuts that you use in pretty much any terminal. But it's different from editors. I actually do not use Emacs shortcuts here. They are nice. They are nice to have.
The other caveat.
And also there is just not that many of them. In Vim, it's a big feature actually to use the Vim arrows. This HJKL or what it was. Yeah. But on Emacs, it's just not a big deal. You just use arrows.
Is that you don't actually know how many characters you're working with, right? You don't, because it's just pointers in the type info. You don't know that, like, that's what everyone talks about with pointers. You don't know how many things they're pointing to, So, you kind of have to guess. You could say, I've got some fixed upper limit. I'll look for a null terminator. The UI can only render so much text anyways, so you can have a pretty small limit, but, not too difficult. With enum values, you can just look at the enum type info, since that's in the debug info.
For me, it would feel foreign now to not have Vimmotions.
Enum type info, see if an integer evaluation, or you'd have it as an enum evaluation.
It's like keyboard layout.
I've got this integer value. Let's try to look up at the enum type information.
It's like typing in QWERTY or Dvorak.
Inside of the enum that there's a member that has a value that matches whatever value I evaluated, and then I use the name. If not, then maybe I just fall back to the integer case or whatever. The only missing piece here are compound types like structs, unions, and arrays. So with a struct, might want something like that, like I mentioned earlier, braces, iterate the members. So this can be done by just, you walk basically the struct members recursively.
Sort of, yeah. But the reason I also use it is because you can describe things that you can't without it.
We've got to say, okay, I'm going
Like sib change inner brackets as an example.
doesn't have to be literally recursive, but you know, the sort of algorithm is sort of recursive. You need like a stack.
Yeah, this is interesting.
So yeah,
I learned Vim at school because at school we actually had to learn it. We had an exam from Vim. But my knowledge of Vim ended at Vim tutor, so I haven't went beyond that. But it sounds like Vim can do some kind of semantic movements, like you describe. It's nice, yeah. Less hitting of arrows. So the thing that Emacs has, which serves this purpose, is search. Like when I'm at like top row, like a typical thing to do is to type Ctrl SL to jump to another letter. So the navigation is, if you want to save on keystrokes, then you use search and reverse search.
you walk the children, you do that. You can get a string like that. With arrays, very similar problem. You've got some, you have some notion of how many elements are in the array. So you can say, well, I found the base address of the array, but to actually visualize this as a string, I want to go, okay, go to the first element, turn it into a string. Second element, turn it into a string. Commas delimiting them. Pretty basic problem.
Vim has this, but it is from normal mode, which is for find. So I can do FA to jump to the first occurrence of that it finds.
What I want to know
Tomahawk KT8 just followed on Twitch.
Hey, thanks for the follow.
which is that
Vim is much more, I would say, the interface is just designed more with human in mind. Like, the interface doesn't really make that much sense conceptually because it doesn't divide those actions into, shortcuts and things. I mean, Vim uses those modes for this. It's a little bit more esoteric, but once you learn it, it tends to stick to your muscle memory better. In Emacs, it's not like that. You have most of the weird actions in Emacs are invoked by Control plus Alt plus something. So you almost never have single letter actions. It almost always requires you to do some key combinations, which is slower. Like if you look at performance and in UI performance, like speed of execution is everything. Speed of execution, I mean human execution, human using the interface. This is what's making the interface feel nice. It's definitely not at the same level as Vim in terms of speed.
But we've got some evaluation. You've computed some evaluation.
Fun thing, when I used to work at Google, basically all of my friends, everybody around me used Vim or Vim shortcuts, like you say, to code. Vim is definitely the more popular
Certain types
option.
produce a set of child evaluations, right? So in the case of the struct, you produce all the members. And if, in the case of arrays, you produce all of the array elements. Another common case, just before I move on, pointers don't always point to strings. Obviously, like sometimes they point to a struct. In those cases, you don't just want to see like, oh, my pointer value is like that. It's like
VS Code likes to do this. It just prints the pointer value. I mean, I don't have debugger attached right now, but it could just parse this track.
you want to see what it's pointing to often, other than struct memory. So in that case, that's also another case of expansion. You just dereference the pointer. That's your child evaluation basically, and then you actually do the recursive path. So if you're pointing at an integer, you print the integer. If you're pointing at the array, you print the array, so on and so forth. It's just one layer of indirection removed, right?
Yeah. I don't mind Emacs-style shortcuts like Eterla, for example. I actually use ctrl instead of ski to exit insert mode in Vim. So it is not the discomfort aspect, it is more about how you can describe what you need, and how flexible these tools are. Speed is definitely a nice trait for sure, though.
Yeah. And there's even this, I guess Vim has some sort of Emacs mode, and Emacs has multiple Vim modes. I know a couple of them. There is Evil, there are whole Emacs distributions based on dynamically switching between Vim emulation and Emacs stuff. The nice things about Emacs are not about its keyboard shortcuts, they are about the modes that it supports. The reason I use it, like the only thing I use still about Emacs is the org mode. This is the mode for doing to-do lists and other such things.
I wonder how many Emacs users actually choose evil mode.
Yeah, I see some posts on Reddit from time to time, but so on there.
You input expressions, and then you just stringify them. You know, they've got type info. You could write a very simple stringification path, if you will, for the type. There you go. That gives you a watch window. But a very useful property of a watch window is not only that you can enter an expression, but that you can also expand them. So this is really useful because, you know, more often than not, like
I've looked into Emacs, but to me, it just seems like NeoVim is converging with it, and vice versa.
You only see the first 8. You don't want to be like, okay, now evaluate array plus 8, and then array plus 16, and array plus 32. It's
Emacs is getting better, but very, very slowly. NeoVim is... The UI is just better, like, executed, say. Like the rendering, for instance. Emacs uses some ancient rendering technology.
CP Chica says,
Mr. Sir.
Hey. But because of kind of Emacs technology, it also works nicely with, for example, SSH. You can do... Actually, on my Windows machine, I have an X server. It's possible to install an X server on your machine. If I run Emacs on my remote machine, it should show up a proper window here. Yeah. So this is actually executing on my router, but because it's using the X protocol, it says Emacs on Protectly. It's actually displaying a local window. I'm not sure. Probably NeoVim also has this, but maybe not, because NeoVim has it's nicer. I mean, smoother rendering GUI framework, I think, under the hood.
Nomadicone says,
Hey.
same thing with structs, especially, you know, you don't want to force the...
Infocy says,
I would be on Linux, but I turn Unreal Engine games into 3D via DDL injection, and I just need the game support. Also, it uses SVC, so Visual Studio is kind of a requirement.
Yeah.
What was the fifth element of entity? Like, let me put that in as a second expression.
By the way, because I'm also building this stuff on Windows, so far, it seems to kind of work well with Clang as the compiler. I'm not using the MSVC compiler, which I guess every game on Windows basically is using, and that makes me kind of worried, because I have this natural reflex to use the most popular technology, because this technology is well tested and guaranteed to work, and all of the problems somebody already solved. So when I'm using Clang on Windows to build this stuff, even though it works, it makes me a little bit worried that there could be some issues ahead that I will encounter eventually, and they are going to be basically unfixable, and that I will have to switch to MSVC and just fix everything, almost from scratch. I wonder if there are any reasons for MSVC. Really on Windows, compared to, other compilers.
Nomad Deacon says,
Are you a software engineer?
Yeah,
That just
a hobbyist software engineer.
So expansion, very easy design extension we could do to the watch window to just speed those things up a little bit.
Imvosi says,
I run this build from TI. I have used GC and Clang, but found some strange issues in the past. More so to do with STD, file system in C.
Yeah. I've also seen there are big differences between the C++ library on Windows and Linux. In terms of new version support. I encountered something very similar with STD source location. It was, I don't remember which library had it and which didn't have it. I guess this is solvable by just switching to some independent C++ library, like the libcxx. The one which is bundled with LLVM. Yeah, I really know a lot more about Linux ecosystem than Windows, so that makes me a little bit uneasy when developing low-level stuff. I'm always worried I'm doing something stupid.
Entity.position, they don't even have to type entity.
Because on Linux, I see people doing stupid things all the time, and I'm pretty sure on Windows I'm one of them.
Position is just there, so that's even faster, right?
CP Chica says,
CD file system source location, stack trace, and thread libraries are submodules when it comes to GCC and Clang, because of their use other than general software development.
Yeah, I remember. You have to pass something on the command line to use them.
The print, sort of the print, writing the expression that you want to print, we don't even have to do that. Lucky for us, we already know how to expand an evaluation. That's why I made that note. It's you take an evaluation and you produce a list of evaluations. You need it for the recursive children walking case when you take structures or arrays and turn them into a string, right? You can use that same path to produce a tree of evaluations.
That was just one bug fixed. So one of those lines with errors went away.
If I evaluate the root level entity, that produces a list of sub-evaluations, which are .name, .position, .velocity in this case.
Imvosi says,
CP Chica, at the end of the day, if it's in the STL, I expect it to work otherwise. I may as well have reinvented the wheel.
I evaluate it, turn it into a string. Or, in general, if I expand it.
CP Chica says,
Because GCC, DCX, DCX by Clang are developed in a way that most of it can be used without native hosts, so no underlying OS needed.
Yeah.
In watch window, either case, I have to produce a list of child evaluations. That requires 1 billion expansions, unsurprisingly. Now, you may think that that's like very contrived or whatever, but remember that the debugger needs to work gracefully with arbitrary code. Shouldn't matter what the user actually puts. If it's complete bogus, the debugger should at least handle it gracefully. Furthermore, if you ever generate an array type, and you're saying the size of this array is actually sized by this variable over here, and that variable's not initialized.
Same can be said for MSVC, but MSVC does not support non-descentaire executable output formats.
This problem doesn't stop there. Let's say you've got a structure like this, some linked list node. You got a next pointer.
There's actually something funny in this. So technically speaking, it doesn't, right? But it outputs object files. It's just a matter of, linking them. I mean, and of course, providing the same OS interface.
Pointer and X.
I guess a clever linker could actually take the object files produced by MSVC and just assemble them into elves. Link them into elves.
X and Y in 32. Whoops. So let's walk through the steps to actually visualize it. We're evaluating node. We want to turn it into a string. Whoops, that goes through all. I guess I can just do that. That's fine. Step 1, push a left brace, descend to next, push string of X, push string of Y. And then we wrap it all up with a closing brace, right? Problem here is that is recursive. So begins the entire process again.
I don't think link exec can link plain binary. Or can it, since kernels are built by an MSVC toolchain?
In fact, a very common case is like sentinel nodes, for example, or like nil nodes. They point at themselves. So you'll just go forever and you have to be able to handle this case, right? So in either case, the Billion array of integers or the recursing node structure, and many other like similar sort of kinds of problems, the fundamental problem here is that we have not properly bounded the problem. We haven't properly bounded the set of information that the debugger actually has to work with, right? The debugger can just like, so far we've only sketched out if like, this is a magical function, you can do this, and then the debugger just calls it and gets a list of evaluations. It's like, okay, now you've got a billion things to go and do. Not really realistic.
Inversy says,
Maffle, do you know what TDD is?
Yeah,
No,
I've encountered it, practiced it a little
You
bit.
can't visualize arbitrarily many things anyways. So it can't visualize a billion integers. It can only visualize like some windowed range of it. There's really only so many visualizations you can actually fit on a screen, right? So you can use those sort of like you can use that fact to sort of form soft upper limits to what you actually have to grab as the debugger. So to do that,
What do you think of it after practicing with it?
like sort of that could expand like that, needs to be windowed.
I actually even used it to develop Automat initially. So I have this huge file called library. And library contains a bunch of objects that I designed for Automat long before I started streaming. And together with this file, I have library test that tests them. I mean, not all of them. It's another test, which is more comprehensive. 7GY test. A lot of text. I think TDD works well if your requirements are well specified. And probably helps a little bit also when they change. But this is the problem with software design, that when you start writing software, you almost never know the final requirements because they will change. So a part of this sport is about putting the flexibility in the places where you expect a change to happen. TDD is nice about checking that you're not verifying any constraints. But it's harder to execute in graphical environment, at least for me. you need more infrastructure, better testing utilities. Standard unit tests are unfortunately unable to cover graphics stuff. I have a friend who works on Dolphin. They have Dolphin is an emulator. So they actually, because they are emulating games, they have this test-driven infrastructure where whenever you make a change, they will run some known games with your change and without it, and make screenshots at specific frames in the game to compare whether the change that you're doing, whether it causes any visible changes in the emulation. So when you get a report, you can literally see screenshots in a screenshot which pixels have been changed, for instance, by your new optimization. It's a cool system, but it's a lot of code to keep it running.
Would you say you write code slower when using it? I feel like a snail when I was trying it.
Probably not, especially now with LLMs. Those huge swaths of code, of tests, there is a lot of tests. I usually end up with 1-to-1, usually the same amount of tests to actual code. But this testing code, I feel it's easier for AI to write it. I don't know. I haven't done any empirical, study on this. It's definitely not significantly slower. If it's slower, then maybe it's a little bit. Not much.
Right. Needs to be windowed. So instead of taking an evaluation, producing a list of evaluations, we need to scope it. We can say...
Maybe the reason why I didn't enjoy it is because I was trying to test functions without typical input-output flow. So,
oh yeah,
dependency injection. And
yeah, this is the worst.
Was not fun.
Yeah, it's pain in Java, in C and C++. You can sometimes do it with the right hooking frameworks or the right macros to compile your program differently, but it's always just awful. I guess in TDD, people say that you should only test the external behavior of the program, not its internal logic. For internal logic, you can always have a debug build with assertions enabled. I guess it solves this issue of visibility.
Maybe that was just the wrong approach, but I only know so much at the time.
Yeah. This is the way. I mean, you gotta try everything to know what works, what doesn't.
That expansion, we produce a list of evaluations just for that range, right? We need some windowed range. When we generate a string, you can't just go forever. Maybe you say, I've got an evaluation, I've got a font, and I've got some pixel range that delimits how many characters I actually want to generate, and then I get a string at the end there. Now, if we imagine windowing a list of rows, like in a watch window, it's a very simple problem, especially because the rows are all uniformly sized, right?
I thought it was the opposite, where you don't test the functionality of the external thing, but you can use mocks, for example, to see if you get back what you expect, e.g. file I/O operations. I don't want to check that it wrote to disk, but I can simulate that environment.
This index to this index, right? Not surprisingly, region before and after, not visible, don't need to do anything.
This is what I get for being overly dogmatic in a topic. It sucks, but I learn best from it.
But
yeah, so there is, I guess, experimenting with new things is a great area to be dogmatic about things. But yeah, I think I also had some tests with side effects. I actually have some pretty side effect tests in Automat, like the performance test that tests whether I can replay events fast enough. This test is naturally, it has to use the operating system because I cannot test event replay in vacuum with just Automat. Automat has to actually interact with the operating system to check if the sleep, if the mechanisms, for example, that I use for thread synchronization or sleeping, some fixed amount of times, if they work reliably. So I have super side effecty tests that can literally hang a computer. They did actually by locking the mouse cursor. Yeah, but then I just run them in a Python script that makes sure it's always cleaned up.
If we take a look at an actual watch window, you might notice it's not really a list. It's kind of this tree structure, right? It's a tree of lists where each list in the tree kind of interrupts the parent list.
It's a very nicely designed tree, by the way. Look how the vertical line aligns with the arrow. And the font, I already mentioned font, it's using compact font to make sure that multiple levels and still with decently long names fit inside the column.
So this...
I am writing a CLI timer as a break from my project, and I was thinking how I can test time.
These are the elements of the bindings array inside of control bindings.
See, I actually had this problem as well. Event bench. So, so the program I'm writing is actually a desktop automation app, so it can automate itself. So it's actually constructed in such a way that it starts itself, tells itself to record, and then stops itself. And then the Python script just checks if it timed itself properly. Some external script, probably. Like one valuable thing I was doing when doing this performance testing was having some graphs that measured whether the timing has bias. Because there can be bias where there can be two types of bias. If you're timing a lot of things, you have a fixed bias and you have a skew of the timing. And Automat had both. So Automat had quite a lot of issues. And this test helped fix them, actually. But Automat is also kind of pretty... it's a pretty demanding environment. Can run it. So you can see that when I have events, those events, they are very dense. So in a single, I basically have event every millisecond. So sleeping for a millisecond is already hard to do. Because operating system APIs, when you go to sleep, they like to schedule another process in the meantime. And you are not getting back in the next, 15, 30 milliseconds. On Windows, it's very bad, actually. On Windows, when you go to sleep, you can go to sleep up to 50 milliseconds. Yeah. So this mouse replay, it required a pretty optimized timing system. Sleeping, scheduling. So maybe some external timing. I would, if I didn't had built-in utilities for testing timing, I would probably go for just a separate. I would just do the measurements from a Python script outside.
oh no. These are the members of bindings at 4. Bindings at 4, yep. So if you encode that hierarchy into sort of a tree structure, if you're just going to like build that explicitly, it'd look something like this. So you've got your watch list, which is just some number of watch expressions, members of.
Okay, this is cool. This is super cool. And this is also how widgets work in Automat. So you only visualize what is currently on screen. And the debugger that Ryan is describing does exactly that. So it checks what you can see in the display, and it only analyzes this memory.
So first, let's label each node. W is watch list, S is shared, C is the members of control bindings, B is the elements of bindings, 4 is the members of bindings at 4. We can also say that each node sort of splits the parent at some particular index in the range. So S, let's just say they all split their parent at S subscript, whatever that node happens to be. We then turn this tree into a flat list, right? You have this tree structure, and each split actually causes 2 ranges of rows to be generated, right? You've got W for the top. You've got W as the top node, and then the things before the splits are W pre, and the things after the splits are W post in this particular case. For one child split, it's a very simple case, right? You've only got 1 split per node, but yes, you've got W pre, S pre, and so on and so forth. 4 doesn't have any splits underneath it, so you just get 4. But you could flatten it this way. And looking back at the original image, we can see these ranges directly, right? Here's W pre, here's S pre, here's C pre, here's B pre, here's all the members of 4.
Actually, I just realized how I can maybe do
And then
it.
we pop back out, right? We've got B post, C post, happens to be empty, right? There's no members after bindings, which no problem. And then we get S post. That's all you can see in this image, but then there'd be a W post.
I have a duration that is specified, e.g. 2 seconds, so I can generate a timestamp, do the operation, and then compare the timestamp with the duration.
Of evaluations, we can then perform the windowing on that structure. You've got a linear list. At that point, you know how big each of these ranges are. Then you can window that list. It's sort of you're performing windowing on a much more limited range than the full set of possible rows, right?
On Windows, I think on Windows, there was an important thing to do. I don't remember if I have this process set up. To get proper times. Yeah, this was necessary. But it still wasn't good enough. I think this allows the sleep APIs to sleep for just 1 millisecond instead of the default, whatever is the default. This time begin period. Fantastically named function.
So in my terminology and the way that I implement this, each one of those nodes in the sort of tree of ranged evaluations or whatever you want to call it, I call it a block. And so to do this step of evaluation visualization, we produce a block tree from an evaluation. So a block contains an evaluation, some root evaluation, and then it says, I'm the range of 0 to...
I don't need it to be too precise since it's a timer where you set an event and it goes off at a time you specify. So I don't need it up to seconds.
These children of that. So, given this example, you've got a vec4 array of 1 billion vec4s.
So something simple like that, like just sleeping for until some deadline, I'm not sure if I would even test it. Because the issues that you might encounter would be, it's hard to reproduce those scenarios. For instance, daylight savings time, or changing the time zone in the PC, or the CPU changing the frequencies, which affects the timer, sometimes depending on which timer you're using, or the PC going into sleep mode and then waking up later. That could mess up, the sleeping as well. It's hard to reproduce those scenarios in a unit test. It's definitely possible. It is just a lot of work.
With the element at, you've got the element at 1 million expanded, so you've like scrolled a long way and then you've like clicked. You get this.
One issue I did find is when pausing and unpausing a timer really quickly, it can actually go backwards in time while the
Interesting.
So if I set a timer for 10s, then pause, unpause a lot of times, it can state it as a 12s timer, etc. That is why I want to write tests for it now.
Mm-hmm. Yeah. I think the C++ recommends to use deadlines rather than timeouts when sleeping. The deadlines don't have this issue with pause and resume. With pauses, essentially, yeah. With deadlines, it's easier to manage what happens during a pause. And there are APIs for that, like sleep until, something like that.
I'm doing it in Python for simplicity. Don't worry about C with STD.
1 billion, and then you've got one node for the members of the 1 millionth, or sorry, 1 million and first element. You hopefully get the picture. When we're actually building this block tree structure, so we have an evaluation, we need to sort of build this block structure here. And the way we can do that is by storing some kind of expansion state, right? We need to sort of have some data structure that records which nodes are expanded. And how do we record that if we don't want to store something for every row, because then we're back in the same problem, right? It's like, I don't want to store 1 billion expansion states, right? So we need to find some kind of sparse representation for that information. So to see how that might work, consider a watch tree like this. You need a data structure which would be able to sort of uniquely pick out certain points in the tree and store a state for them and store only those expansion states. So let's say A, B, C, and D. Those are the nodes that we want to sort of be able to uniquely define. And then once we have that data structure, when we're building the block tree, we can go ahead and say, here's my spot in the tree, check if it's expanded in the sparse expansion state, and if it's expanded, then we recursively descend, right? Then we build another block in the block tree. Oh no. Okay, one way of defining A, B, C, and D for any tree is to store a walk from the root node of the tree down to whatever child you're going to end up at. So consider that we know each index within some parent of one of these rows. We know the index within its parent, right? So we've got 1 is the first one at the root level. We've got 1 underneath that.
Be right back.
And then we've got 1 and 2 underneath that. This node's ID can then be encoded as, okay, well, we start at 1 and then we walk to 1. Here, you start at 1, you walk to 1, you walk to 2. That's that. That's how we can encode that position in the tree. Here, unsurprisingly, 1 to 1 to 1. Now, okay, right. One undesirable property of this is that this is like a variable length encoding of a particular spot in the tree. We have to store this chain of walk steps to get from the root node down. And so all your IDs become variable length. Now, obviously, you could just do that, but I figured I would include how you don't do that or how you don't need to do that. A simple way to eliminate that would just be first we can consider it as sort of a parent ID and then some child ID. So we have some encoding of the walk from the walk to the parent, and then we encode the additional step that we take at this particular spot by saying, here's my child index or ID or whatever. So this node here, the yellow, the one circled in yellow, the way we define that key is, we have some encoding of the walk to the parent, unique child ID. This one, same thing. Really easy way to do that, get a cumulative hash of the walk. So basically we start with some default hash and then some ID for the root node, and then we hash that, and that's an encoding of the walk to the parent recursively, right? So for the middle one there, we hash the top one, we get some ID. Similarly, oh my gosh, this thing sticks. Okay, all right. That one, ignore everything you just saw. That one, you hash the parent and so on, right? So then, because you can have these like sort of unique keys, it's pretty easy at that point to have a sparse data structure that's like, look, we're only talking about the hashes and IDs that have actually been expanded, and then you can actually, look it up and produce the block tree, right? So let's zoom back out. Start with an evaluation, which again, that's produced by the compiler, by the debugger's compiler. Using the expansion state, you can produce a block tree. A block tree can be used to produce a list of pairs. You can think of it, each pair containing, you've got some block and then some range within that block. So that would be like, the W pre, S pre, and so on. That would be like that step. And so that forms like the linear sequence of blocks, right? You've got like these rows and these rows and these rows and these rows. And you're not doing per row work anymore. And finally, remember that we have a way to take an evaluation, and given some range under that evaluation, we can expand it to all the children evaluations. So with that list, you can produce a final list of row evaluations, right? That's how you, with the global viewing range, you can use that together with the list. This is the windowing step. You get the list of actual evaluations that you can use for all the rows that are visibly available in the watch tree. So let's take a step back, think about what this actually gets us. In terms of like our overall goal, right? Our idea, we want to accelerate visualization. What does all of that crap actually get us? So I've covered almost all the steps besides the UI part that you would need in order to build like this kind of watch window structure. Right? So this is like a fully windowed one. We only evaluate what we need. We don't pull in memory that's not visible. None of that happens. And then obviously we visualize everything textually. We've got a struct, you've got members of the struct, some of them are integers, some of them are structs, whatever, we show the textual representation. And that's great, we can dig into anything the debugger can evaluate using its compiler this way. We've done sort of a general textualization case. But in a sense, all that is, we've kind of just accelerated printf debugging. We've kind of just produced a type-aware version, right? So in C, it's really stupid. You have to sort of just say like, you have to remember the type info and say, well, I'm gonna log this struct, I've got a printf header, like in this case, I'm at my hit entity code path, I've got header.id, I've gotta log that, header.parent, I'm just like duplicating the type info at this point. And I've just gotta remember how to do that, or maybe I just narrow down to the subset that I want, whatever. In a better language, maybe it'd look more like that. you've got printf and then header, maybe it's not even f, I don't know, header and then percent, and then you can just pass the struct. Maybe it should just be aware of the type info somehow. Obviously not the case in C, but point being, the watch window effectively provides an accelerated version of that. Now the watch window offers some pretty big improvements, right? The ability to interact with the data. You can write to the data. You can dynamically expand or collapse parts of the data. It only pays the cost for what is visible. You don't have to literally log everything and then hunt through it. And you can also interactively go to other parts. You can evaluate as you need instead of having to evaluate everything and print it and log it, and then search through the sea of log that you get. So eliminates the code modification step, eliminates the build, eliminates the run, eliminates the recreate state. But we already know that text is insufficient. So
this is the interesting bit.
To support non-textual visualization.
This stuff before was also interesting. I'm pretty much it's pretty much clear that you don't want to, for example, represent in the UI hierarchy the nodes or variables which are never being shown on screen. Yeah, don't compute what you're not going to need.
Visualizers as well. No. I'm really bad with this thing. Okay, so let's consider a basic case of visualization, right? Instead of single line text, we've got multi-line text. So in this case, I've got some shader blob. I've got some shader program text that I'm evaluating. And our watch window kind of just shows this. You get the string, you're here's my pointer to the string data, you expand it, and it's oh, that's pretty good. I can see the characters or whatever if they're ASCII. It doesn't even support UTF-8. I don't really want to look at this if I'm what's this string? That's bad. Now, one potential alternative is hex editor, right? Memory view kind of thing. And this is often actually good for this. If you're writing a parser or something, you can look at the data this way. You can position your cursor maybe at where the parsing iterator is or something, so you can see how it's treating maybe usually invisible characters like new lines or whatever. So this isn't it's not useless to look at it this way. But more often than not, if you're working with textual data, what you'd really actually prefer is an actual visual, just show me the text. You know what I mean? You kind of want to just treat it like a text file, like that. So, all three of these visualizers might be useful at different times. One on the left, kind of the odd one out, kind of sucks usually. Not universally, maybe you can imagine the case, but point is, all three of these, different ways of looking at the same data. Same type, same format, different visualizations. And importantly, the user's got to be able to choose. As the debugger, we've got to provide the ability for the user to pick between these three things. We can't enforce it on them, given the type info or something. Okay, so far I've covered these three steps. We've got the compiler, got the interpreter, and then we've got or a virtual machine or a CPU or whatever. And then we've got the windowed watch tree build down here. The final missing piece of this is you've got the watch tree build, and you've got to produce some UI for it. Right? You've got a list of final evaluations you get out of this. You've got to produce a UI for it. Now, started by introducing the most basic one. You produce a textual representation for each evaluation, put them in a little watch window UI. That's fine. The UI build for that's not conceptually difficult. It's an Excel cell, it's just like Excel for your program data. The full watch window is just like a table of those cells. First cell would be the string representing the expression. Second cell would be the string representing the value. Third would be the type, and so on. But it's at this stage that other visualizers can actually slot in. Right? If we want to take that path and override it to do something else, here's where we actually do that. So instead of taking our evaluations, feeding them into a value string text generator, we could also feed it into a bitmap visualizer, oh no, 3D geometry visualizer, disassembly visualizer, pointer graph visualizer, right? Or anything you can think of, this is where it would slot in here. So the way I think about this is that all of these different visualizers
Lens is a nice name.
like lenses into our data, right? You can just take an evaluation and view it like literally like a physical lens, right? It's changing how you're looking at it.
Yeah.
So 64 megabyte buffer can be viewed in many
Also
ways.
interface.
It can be viewed through a bitmap lens, a hex editor lens. No, please stop doing that, dude. Or a text editor lens, or many other possible things. Now, a complication arises, which is that not all the information to actually produce a visualization is present inside of the evaluation, right? If I want to visualize a bitmap, what dimensions am I talking about? Like, what are the dimensions of the bitmap? Which format is the data encoded in? If I'm looking at geometry, is this like vertices or indices, or what is it? What topology is the geometry? What's the vertex format? Like, how are these things laid out actually? How's the different information laid out? With disassembly, what architecture, what syntax, how many bytes do I want to pull down and actually visualize? And so note that all of these questions are like...
Okay, I will be super impressed if it's possible to do this kind of stuff that he's describing without cooperation from the app. Like, imagine an adversarial situation where you're reversing a piece of software and where you could apply those sort of visualizations to analyze its structure.
highly specific. They're parameterizations.
I'm back. So when you say you were doing TDD in Automat, was that doing red, green, refactor?
It was more like I first implemented a bunch of tests, but the tests that I implemented weren't quite unit tests. They were this 7GUIs, it's a programming benchmark, essentially. So I implemented basically solutions to these tests, to each of those 7 tests, in a fake imagined version of Automat. And then I started filling the necessary objects one by one. And there wasn't a cycle. It was first I wrote the tests, and then I was spending the next 2 weeks making them work. So not in this granular loop that some people may describe.
Express.
Depends, if you're iterating in a very tight iteration cycle, you only see local problems. You don't see the ones which are further away. It's usually fine, but if you have the patience to refactor everything all the time, yeah.
Okay. So to solve this problem, we need to have some way of obtaining from the user a choice of visualizer and a choice of all that visualizer's options for some evaluation. So if I've got this buffer evaluation and its array of 64 million U8s, I need to somehow tag it. I need to somehow take that evaluation and just tack some information on. That's by the way, I want to look at this as a bitmap, 1024 by 1024 RGBA8 or something. Lucky for us, there's already a way to tag an evaluation, and that's with type info. So we can use type info to express all of these visualizer decisions. So we already have paths that rely on type info, right? Remember when I turned it into a string, I had to look at the type info.
I think when you use the iterative approach, you can refactor quicker because you will catch when you break the tests you already had passing before. However, it's like you said, you are working in a smaller scope, so problems further away you may not know about yet, and that can become tedious really fast.
Global variable, its type is a 64 megabyte array.
Yeah, and different languages have different levels of tolerance towards refactoring. In Go or Java, refactoring is, super fast. But in stuff like Rust, each refactoring requires you to solve the borrow checker Sudoku.
So all we have to do is extend our evaluation language to be able to extend that type information. Conceptually, it's almost like it's actually not just a cast. It's sort of like it's sort of appending onto the type operators, if that makes sense. I guess it is sort of a kind of cast. You take the 64 megabyte array of U8s and then you sort of cast it to bitmap type, special type, which points to that type, right? So, like, if we look at this expression down here, you've got like this bitmap call. It's like looks like a function call, bitmap, and then you've got some buffer, and then the parameterizations of the bitmap visualizer. That's just a type now, or that implies that the type turns into this. So in one step, we've allowed our expression language to express both a choice of visualizer and any set of arguments to that visualizer. So our UI build, by looking at the type information, can then decide appropriately on the visualizer path. Like, do I have a visualizer type operator or do I not? So our visualizers fill this part out, right? We've got some evaluation, we produce a UI. Pretty straightforward, hopefully. And recall that an evaluation implies an abstract syntax tree, an intermediate representation, a type, and a value. And the type implies all the options for the visualizers. So now, okay, let's back up. We've got these lenses. We can extend type information to include arbitrary visualizer parameterizations. Let's take them a little bit further. So let's imagine types like this. You've got, this is very common in C code bases because we don't have nice things in C. You've got struct foo slice, you've got a pointer and some count, or if I've got a list like struct foo node, pointer to the next node, and then a member with the actual data. So given the current sort of type info visualization rules, you put that into the watch window, you're like, great, I'm gonna visualize my dynamic array today. You expand it, and you've got two members, it's like V and count. And then you expand V, and it's like one thing. And you're like, what is that? Same thing with the linked list. You like put in the head of the linked list, you expand it, and then you can actually recursively expand it, but like in your head, a list is flat. And then everyone's like, who's used debuggers knows like to visualize a linked list, you've got to like expand it and then expand it and then expand it, and then it's like, what am I even looking at some point, right? It gets really ridiculous. So taking a look at the visualization pipeline, we know that our lenses, those lens type operator things, they override this part. Like the arrow here, which is like, turns a list of evaluations into a list of UIs, right? Because we can take an eval, produce a UI, which means we've got a list of evaluations, we can produce a list of UIs. We can override that using that type info. Same pattern, we can also override this, right? We can just say like, hey, we're gonna change the way we're gonna build this block tree. We're actually gonna say like the type info can now have some say in that stage as well. So instead of visualizing these two particular structures like this, we can now actually introduce some lens types which have custom rules for how to build the block tree here. So for the left, let's say I use the array slice and I'm like, you got an array, here's the pointer, here's the count, give me the block of all the elements. On the right, I've got, here's the head pointer and here's the name of the member I want you to follow to find all the list elements. Give me the list of elements, and we can just do that with the type info. No, I'm so bad with this. Okay, so I've walked through this whole visualization pipeline. It allows us to just visualize in the ways that I've showed anything the debugger can evaluate. And so far, anything the debugger can evaluate has just included like expressions relating to your program, like a debuggy address space, or something in a thread register inside of a debuggy, so on. But let's consider all of the scenarios where we have some data from anywhere that we're looking at and we want to understand it. A significant subset is what I just said. It's like somewhere in the debuggy memory, debuggy registers, whatever. Like I said, walked through a pipeline for visualizing stuff from that. But let's appreciate something here, which is that this is a subset. And like in a very large number of cases, actually, it's also common to look at memory from other sources like the file system, right? And turns out people have built an enormous number of tools to work on data from a file system, like IMHEX, looks like maybe a little familiar. 10x views source code and editing.
You record them. They sound like interesting tools. IMHEX.
Turns out people have built an enormous number of tools to work on data from a file system, like IMHEX, looks like maybe a little familiar. 10x views source code and editing source code, obviously. Beyond compare, take two textual buffers, compare them, show me how they're different. And so there's sort of this unfortunate problem emerging.
So the one I like is actually Wireshark. Wireshark, compared to those, has a really nice repository of dissectors. A dissector is a program that can analyze the structure of some bytes. You tell it the type, or even ask it to guess the type, and it breaks it down recursively into sections of bytes with meaningful interpretation. Each of those dissectors can produce human-readable descriptions and parse the values that it's dissecting. So Wireshark dissectors is the one I'm familiar with the most, and that I am planning to integrate into Automat. But IMHEX also looked interesting. Maybe IMHEX also has some ability to dissect binary formats. And 10x is probably not very interesting for analyzing memory, but who knows? Would be an interesting program by itself.
Wireshark is for networking, though.
Not entirely. You can also drop regular file into Wireshark and it's going to parse it. I use it to analyze ELF files. Wireshark, kind of slow to open. Okay, I guess I have to update Qt or something. Yeah, it's not going to start. But I use it to understand the structure of executable files. It has a nice, like the built-in tools within Wireshark, they just happen to work nicely with parsing any file.
Merging, right? We've got these two worlds where it's like our debuggy world where we build all these cool debugger visualizers. We've got a hex grid, we've got text, we've got a bitmap, and then it's like, wait, on the file world, I've also got a hex grid, which would be something like IMHEX. I've also got a text viewer or editor, and I've also got a bitmap viewer. So like, what's kind of sucks, right? Because each visualizer is sort of like coupled to like where the data is coming from. Like these only apply to like reading process memory. These only apply to files.
Yeah, and this doesn't make sense if you think about this, because you can just load those files into memory and they could all be kind of operating in the same space.
Because like the one on the right is more common, right? Like everyone's built tools for this side, and comparatively few people have built tools for the left side, it's sort of like it's just more worth it to build tools for the right side. And so like the debuggy visualization stuff kind of suffers a lot. It's just more worthwhile to do an investment on the right side than the left side. Just get way more bang for buck that way. What's worse is if we consider the needs of an actual debugger UI, we have to do the file system part too. Like we have to look at a source file on disk, we have to pull it down as text, and we have to visualize it as text. So for me, like this was just like too much. I'm like, when I first built the visualizer system in the RAD debugger, I like was starting to have like, here's the source viewer, and here's the debuggy process memory text viewer, and they're bifurcated in this uncomfortable way. And I'm
One thing about Linux is that there are very few instances where this happens, but any program can become a Wayland server or an X11 server for another program. So it's possible to embed programs one into another. I wouldn't say easily, but it is possible, and some programs do this. So, technically speaking, it should be possible for a debugger on Linux to embed arbitrary text editor inside.
It was like, there's too much, like these things should be the same. Like I had a feeling that these should collapse.
On X11 it will be the easiest. On Wayland, probably less easy because you would have to juggle textures. But in both cases it should be doable. I mean, if you go crazy and write your own kind of hooks, it should also be possible on Windows. But this is another level of complexity.
Why do I feel that way? Because past the point of actually reading the data, it's like the same thing, right? Same problem. But remember I said our visualizers in the debugger can apply to anything the debugger can evaluate. So what can the debugger evaluate? So far, a debugger evaluation can produce like an address or a register or a value, or register location, I should say, or like a constant value of something. But if we extend the notion of an evaluation to also include a notion of which space, which universe that evaluation is within, then we can broaden the applicability, right? We've sort of parameterized this thing a little bit more to say a little bit more about where it is and where it's coming from. So a space can be used to choose between a debuggy, obviously, but it can also pick between, let's say, another debuggy. Let's say your debugger is not just attached to one process, but multiple processes. Which one are you evaluating in? A space can tell you that, but you could also say the space is a file, or the space is just some file on disk at some path, or it's something in the debugger itself. So if we expand that, then these different worlds simply become different spaces within which the debugger can evaluate. So remember that source view in the RAD debugger? That's just the text visualizer applied to a file path. The output tab, just the text visualizer evaluating the output log within the debugger space. What happens if you open a binary file? It's just a hex viewer, because the debugger has a way of viewing memory from any space with a hex grid. So that's how that actually works. And it doesn't stop with the visualizer sort of.
It's crazy. This is how it looks when C programmers discover object-oriented programming.
Endpoints.
Crazy. It's crazy.
You might also remember, like when I added a condition to a breakpoint, I right-clicked on the breakpoint, this UI pops up. Kind of looks like a watch window, doesn't it? You may think it looks like one. Maybe. And that's because it is. It's an actual watch window evaluating the breakpoint within the debugger address space, or not address space, debugger space. And it doesn't stop with breakpoints. All configuration data works this way if I evaluate a target.
But I agree 100% with Ryan. The object-oriented view is the right way to look at computer memory. It's very flexible. It allows you to have those multiple parallel views, lenses, as he calls them. The same thing that we do in our heads when we think about a program. And it also allows a lot of code reuse.
All the options for launching an executable, That's just evaluating the target. Looks like a watch window because there's one. Here's the list of threads in the RAD debugger. Need I say more? It's a watch window. Tab right-click menu. Yes, I know it's a watch window. File tree view. Guess what? Watch window. Just evaluating folders. Everything's a watch window. Everything's a watch window. Now, to build visualizations for the system, a visualization engine needs visualizers that are sort of agnostic to the source of the underlying data. So in other words, they need to be based around like some contents. Like you want to talk about the contents of something, not like the path to that data, because that couples it sort of to the file system, right? So let's imagine a file-based viewing program. In that case, the user is like, I'm going to view this path, and the program produces a UI. If the code is written exactly like this, then the UI path is just completely wound together with the idea of pulling the data from the file system. Now, a content-based viewing program produces a UI given some blob of data, whether it's read from the file system or from somewhere else. So the input is the data instead of the path to the data, since the path is coupled to the file system. Now, we know that in the debugger, the user can refer to content using an evaluation. So let's evaluate. Let's imagine what we need in order to build a bitmap viewer. The user specifies some evaluation, some visualizer parameters, and we need to map that to some data and present it as a texture somehow. That might require like uploading the data to the GPU and obtaining a handle to a texture, and then we render with that texture. Now to do that, we might need to do something like these steps, like given some evaluation, you extract base address and a space, you extract some memory size, which you would get from the visualizer things, because specify the dimensions, the format, you can infer the memory size. You need to read the memory from the space, and you need to upload the memory to the GPU storage, right? Now, the naive implementation of this would just put this straight up into the UI build, right? The UI is just going along, it's like building buttons and stuff, and it's like, need to build a bitmap viewer, let's like get the base address, the space, get how many bytes I need to read all the memory, and then upload it, and then get a texture handle. So that's the naive implementation, you just do that all on the UI thread. You run into a problem with that, unsurprisingly, which is that the size of this data is unbounded. You have very few constraints about how large this can actually be. Which also means that is unbounded. These two things are unbounded. So remember, like everything up until this point, I've been like talking about how to window a watch tree. I've talked about how to like scope down what the debugger is looking at, because otherwise our debugger UI is going to have way too much stuff to do. You've got just so much memory to read, so much stuff to build. All like half this talk has really been about how do I scope this down? How do I not do all that work? And I've just like completely eliminated all of that with this step, right? Furthermore, this isn't a windowed problem. Like you can't really window this part. It doesn't really fit the pattern. Other visualizers, similar problem. To visualize text, pull it all down. Disassembly, pull it all down. Geometry, pull it all down. Pointer graph visualizer, you gotta like walk the pointer graph and build it up. And so you need this like large data preparation pass before you actually go and build the visualizer UI. So putting this non-windowed stuff in the UI build just compromises everything. It just ruins everything else. If you do this, it's like nothing was gained. So instead, ideally, the evaluation and UI paths use light keys to the data. So they say, I've got some light key which can be used to get to the data, which this is what, like, when you use a file system-based program, this is what the path is, right? You've got some light key, it's much lighter than the data, which you can use to get to the data. And then the UI thread wants to sort of use that key and sort of like tell some system, it's like, look, I've got this key, go and read and prepare this data for my visualizer. And then when it's ready, I'll build the UI with it, right? So even if some data preparation task takes like n frames to actually execute, the debugger's UI can continue just going along smoothly. A very simple way to produce a light key, which refers to some data uniquely, is to take a hash of the data. So instead of reading all the data for some evaluation every frame, you map it to some hash of the data, which can serve as the unique key to some content. So our background data preparation threads can use that hash to obtain the data and then process it, and so on. So the first thing we need to do that is just a cache, which maps from a hash to a data, right? We've got some data structure in our program which says, hey, look, you've got a hash, here's how you get the data for the hash, done. This has the added advantage of like, this is deduplicating everything, right? If you hash the same data twice, you can trivially see that when you implement this data structure, it's like, oh, these are the same thing. So just, don't actually store it twice.
One thing which is not quite clear to me, you mentioned like a minute or two ago that data to be read is unbounded and hashing unbounded amount of data is going to take a lot of time. So maybe he's talking about hashing the keys, those sort identifiers that identify the source and range of data, and not hashing the actual data. Not sure.
Then you can build a number of other caches which also store the...
Or maybe this happens after the data is read, after he knows how much and what data is in the system. Maybe this hash is just used to, I don't know, connect data to textures.
Processed sort of data representations. So you might have a cache which maps a hash and the parameters to a texture, hash and parameters to a text and like a parse of that text, sorry, not the text. The text is just the data, but the textual lexicon parse of the data. Got some cache for that. Hash and parameters to some vertex and index buffer. And then our UI thread, when it's building a UI for a visualizer, can just read from these caches without doing the data processing itself. So when you're building a bitmap viewer, you just read from that cache. When you build a text viewer, read from the text cache. When you're building a memory viewer, there's no special cache you need. You just get the data from the hash to data cache. And then when you're doing a geometry visualizer, unsurprisingly, everyone can tell, you just read from that cache, right? And again, instead of the UI thread doing that work, you've got these background work threads that are filling those caches as needed. So the UI thread can request some hash. It's like, look, I've got this hash from an evaluation. It has these visualizer parameters. Please give me the thing. And then the cache can say, hey, buddy, don't have it yet. UI can say, like, no problem, bro. I'll just, go and draw an empty screen or whatever, or an empty visualizer in that case. Point is, it can continue along smoothly, right? The UI is not blocked, the user's not blocked, which is priority.
Yeah.
So taking a step...
It's very interesting that this architecture, Automat follows the same, the identical architecture essentially. It's very interesting that neither GTK nor Qt do something like this. They are all essentially, you have this resident state that you are building that describes the UI, and there is very little asynchrony. If you build a UI, you want to display it, it has to fully draw it to be displayed. There is no notion of drawing empty space when something is not ready.
Back. Let's think about some pseudocode we might write to build a bitmap viewer. You get some evaluation, it's like passed into the bitmap viewer, right? Again, this is implementing eval to UI, that arrow. Get the eval, get an address, get a width. Again, these are all implied by the type info. So we get an address, width, height, format, size, hash from some space and some range. We can get a texture from some hash in those parameters. And we can draw the texture, right? Pretty like pseudocode, high level, but hopefully that sketches it out pretty well. So nervous to press it. Now the last thing I'd like to cover is one problem we've introduced by switching to content-based visualizers. And that has to do with how, like, you have a hash, the hash can change across time because a program is mutating some data, so you get a different hash when you actually hash that data. So, if you step, like the hash of many things will change. So imagine this scenario, we've got some visualizer, it's got an eval to a hash, get some hash, which maps to some visualizer data. At time 0, like we were building the UI at time 0, A and B both pass. We get an eval and a hash, we get a hash and a visualizer data. All good, we build the visualizer. At T1, we get a new hash, but B is still preparing, which means we do not visualize successfully. And at time 2, B has actually completed again with the new hash, and we can continue building the UI. And what this manifests as well, maybe unsurprisingly, is at time 0, you get a picture. At time 1, you don't. At time 2, you get a picture. It's flickering. It gets harder to track how data is changing across time because you've lost that sort of, what the file path was providing was sort of the identity. It's sort of this key that refers, it's like the name of the thing, but not the content of the thing. It can refer to the same thing across time. We lost that when we moved to content-based visualizers. So how do we get it back? And really, maybe not surprising, we really want to map to some key which can get us to a list of hashes, like a history of hashes, if you will. And at that point, once we have that, once we have some unique identity which can refer to a history of hashes across time, if we're at time 1, we know B fails, we just roll back. Just, okay, grab the previous results, keep building the stale results so that the user's not like seeing stuff flash in their face when they're trying to see how something is changing, right? Furthermore, this step is the first step to solving a different problem. So while this kind of debugger visualization engine can be pretty good at like looking at things quickly and interactively and seeing data at certain points in time,
very important thing.
Still lacking something that logging provides, which a log kind of covers a whole range of time. This visualizer kind of sort of like pokes into points of time and shows state at those moments. So by mapping an evaluation to a history of hashes, rather than just a single like most recent hash, we've actually introduced some of the machinery we need to start rewinding the clock. So this way we can see like an entire history of changes to some evaluation. That sounds an awful lot like a dynamic logging system. But at this point, we've reached the boundaries of all the work I've completed on this problem and kind of what I was able to fit into like this level of detail and this time. I realized that was like probably a lot of information. But we've walked through all the building blocks of a general purpose, real-time debugger data visualization engine. So from process control to expression compilation and evaluation, to debug information, to windowed watch trees, all the way to visualization systems. Now, there's tons of problems in this space that I have not like explored, and so there's always much more to do. There's always so much stuff.
Yeah, that was an excellent talk. And the description of the architecture of the UI is also very nice.
To do in this space. And there's a lot of like implementation details that are interesting that, obviously I need a higher level of detail than what I could get into just to cover all this. But I'm happy to expand on them if anyone has questions. So, all right. One thing I hope to get across is not only like how this kind of system works, but why it matters and why it's an exciting and sort of fruitful area of development. Computers, very opaque. I know we have all looked like this at some point. In order to do a good job at producing good software, we've got to have a strong understanding of what we're doing. We have to have a strong understanding of how our data is changing across time, and we do that better with visualizations. So, just like to say, I've been working on this problem for a few years. Really proud of the progress I've made, but really happy that I was able to come and share it with everyone here and then online. And I hope it was interesting, informative, and helpful. And again, thank you to Sam, Sandra, and Charlie for the opportunity. And Casey's gone now, but and I know we've piled tons of thank yous onto him, but I wanted to put one more in my talk. A lot of my work on this problem required like lots of insights and lots of like everything down to like programming techniques, but up to and including stuff within this problem that I covered today. And a lot of that came from insights that Casey shared years ago, not even with me, but with people like 10 years ago. And he told me about it. I'm like, wow, that needs to be implemented. Like, that's a really good idea. So Casey is like, none of this would have happened without him. I wouldn't have my job. None of us would be here. I wouldn't know how to do it. I wouldn't know how to work on this problem were it not for everything he did. And so, yeah, I mean, tons of props to Casey, obviously. But finally, thank you all for listening. Thanks for bearing with me through all that stuff. And thanks to everyone online for your time and attention. And that's all I've got. Thank you.
There will be a session of questions now.
All right.
Quite often the questions are just as interesting as the presentation itself. So we'll go through those questions, but first, I kind of got lost in the presentation and I wanted to analyze one weird error. So maybe I will take a look at Automat a little bit and we will get back to the video in a couple of minutes after I fix this one bug that annoys me a little. Let me maybe print this path a little bit more. So first I want to debug what are the paths that the system can detect when I'm moving my pointer around. Should see them in the terminal, but it's root widget, root machine, location, timeline. Problem is when I'm over those fields in the timeline, this doesn't seem to work. We end at macro recorder level. So there is something in the, I guess, location transform, which is probably broken. These fixed parents. We'll add it to code cleanups. Replace this function with a debug assertion. And I don't need this function, I think, because I'm setting the parents properly. I look at the changes that I've done in this file, the problem should become apparent because it used to work before I did all of those changes and now it doesn't. So clearly something must be wrong here. Let me take a look. The issue could be here or it could be in the header file as well. It's a reference counted widget now. Widget used to be reference counted. this object widget.
BW, I had a question. It says in your bio you did competitive programming. I take it you did leak code?
Not lead code specifically. I was doing... At my university, we had some kind of local Polish servers. There was... one of them was called Spoi. I think Spoi still exists. Let me try to... Yeah. And there was one more. I don't remember very much. They are very similar to lead code and top coder. And those were just preparations for the competitions. The competitions were between schools.
Was you bad at spoing when you started?
I started kind of in high school, so before I came to uni, I was doing the there are those Olympiads in computer science. They are essentially lead codes. I'm not sure how they are called in English.
I tried leak code like 2 months ago or something, and I was humbled fast.
Yeah, it's hard at first, but it quickly gets easier because most problems are from a couple typical categories. You have graph problems, which half of them you solve with search, and you have dynamic programming problems, which are snowflakes, but all of those snowflakes can be solved in roughly the same way by identifying the optimal subproblem and chunking the solution. Yeah, and a couple unique algorithms. And it's fun. It's like...
Yeah, I discovered it is pattern recognition, more or less. If you understand the topic you should use to solve the problem, it becomes way easier.
Daisy says.
Do you use lead code?
I don't remember. I probably never created an account, but I know what lead code is, and I know lots of people use it. The stuff that helps a lot is there is like a list of common algorithms, and if you implement this algorithm once, then delete the code, then implement it again, delete the code and implement it again, after 3 or 4 rounds, you tend to be really good at it. And it's something that can be learned in basically a day or 2 for each algorithm. First implementation is always the most painful, the slowest, but then it gets faster and faster. And then you have this memorized almost program that you, on an actual competition, when you recognize a problem, you can then repeat from memory very fast. I could probably do, I mean, DFS is very simple because DFS and BFS, regular search. But those you can do with closed eyes, literally, and I'm not joking. You can literally implement them without looking at the screen.
Embassy says,
I actually used LeetCode to practice some TDD, aha. Definitely overkill, but it taught me a few things.
Most important thing is to have test cases. Yeah, this is actually... algorithms and data structures, at least the way this is done in LeetCode, is very like TDD. The thing is, on a competition, you don't get access to the test cases, so you only get information that, sorry, you failed. It's very hard to sneak out any sort of debug info from your evaluation.
Basie says,
Yeah, that's what they teach us at CP science class. For example, sorting or finding prime numbers most efficiently.
Yeah. I'm looking for things that I could have messed up here. I could have messed up this.
I like bubble sort the most.
It's also my favorite. I have a personal attachment to bubble sort. One of the first algorithms I wrote was bubble sort. I was scripting an inventory system for an MMO, and I needed to deduplicate items. You know, if you have, for example, herbs or potions in your inventory, I wanted to write a script that kind of combines them together. And like one way of detecting unique elements is by sorting them, and then you can iteratively work through the sorted list and then combine them if they are the same. So yeah. I still remember that. It's like one of those programmer memories.
That sounds cool.
Yeah, and the way to do it is to use hash maps, like everybody right now will tell you, but hash maps are kind of not very obvious. Somebody has to tell you how they work before you can use them. This should be fine. This should be fine. Drawing works. Even do this.
I was learning how game cheats work with the memory, and it's actually pretty easy. The worst part is anti-cheat bypass.
Yeah, it's like a superpower when you know how memory works. Very simple programs which don't have any protection can be cracked in literally minutes. all of this looks reasonable. I didn't broke anything here. Maybe here. Start. No.
Yeah, assembly is easy.
It's also how scripts work in Automat, right? Because I think individual instructions, they are conceptually simpler than most programming languages. You cannot make syntax error here. You just check if a flag is set and then jump somewhere. Or current time. I can execute this instruction and get current time in 2 registers. I mean, it's tricky. I still have to combine them somehow. Maybe shifting them. What do we have? Rotate. Can do it like that, and then or now I have current time. Oh, actually I did it the wrong way. Anyway. I'm looking for this bug that I introduced. It has to be somewhere here. All of this seems to work. Again, drawing seems to work fine. The mouse pointer seems to be broken. Something is wrong with it. This also looks fine.
Embassy says,
Maybe you can relate, but test doubles made me start to not love OOP as much as I used to.
Yeah. Because testing doesn't really bring you closer. Like to solving a problem. Testing is just a verification method, right? It's just overhead. So it's not fun kind of OOP. OOP is fun in games, because in games when you design game systems that are supposed to interact with one another, then OOP leads to very fun interactions between those objects. For example, enemies can accidentally kill one another instead of hitting you if you position them properly. If everything is nicely object-oriented. very few places where OOP works nicely. It works nicely in computer memory, like the debugger that Ryan built. It really shows the power of OOP. And this, I find it funny that he didn't use the term object-oriented programming in this talk. I think it's interesting. I would like to ask him what was the reason. Maybe somebody will in the QA session. I mean, I would guess this is going to be the first question. Update child transform, yes. This is...
Well, fix the bug and you can find out.
Yeah. Okay, this is the place where I expected the bug to be. But it looks perfect. Actually, no, this should also be fine. So essentially the hover animation is broken, and it's broken probably for the same reason that everything else is broken as well. There is some coordinate transform issue done wrong. So when I'm moving my mouse, it properly shows the tree of widgets from root widget. Then there is root machine. Root machine is this huge white area. Then there is the location, which is like a meta object that holds every object, like a variable, and then timeline. And I can point to any object and it works. It even follows the paths pretty accurately. The transform seems broken. Maybe, okay, there's another place which could be broken. Transform between. Where is this widget CC? I will have to, I guess, debug this function somehow. This is the point where I'm actually going to use the stuff that they described just during the presentation. This is printf debugging. The power of printf debugging.
Print debugging is all right.
Okay, this function is recursive. Okay, so I am actually descending properly. Just for some reason, those final objects are not appended to the path. Though this printf debugging, it used to be more painful. Now that we have smart code completion, it's writing itself. Okay. So when I'm pointing at hotkey, it's saying something weird. Power button pointer at... Okay, this is independent of zoom, but it's dependent on the position of object on screen. Ah. Yeah, transform down is wrong for some reason. If name is equal to Scully. Power button. No, that should be it. We'll put a debugger here. First, I will set up a test case, which is going to be just an empty automat space with just a hotkey object. I'm just building a debug build, not running a debugger yet, because I don't want to pause it right now. I just want to set it up. Looks as if this local to parent was initialized badly. It should be initialized here. Hotkey in here, and this should say debug. Okay, it says. It's very slow to start. This is probably because of my Python script. Probably doing something weird. Come on. Start up. Should work. I have this scenario. Now when I point at this, I get this debug message printed. So when I activate the breakpoint, I should now be able to pause at the right point. Now, widget, this is a toggle button, yes. Target not available. Anyway, it should have matrix, local to parent, which is a unit matrix. Curious. Parent is a hotkey, and its matrix is totally broken. What could that be? I think I know. It's because of the clone function.
This music is giving me Tron vibes, Link.
Live automat.org. This is the stream overlay. It has a music repository. Quite frankly, I was doing this music in Suno, some AI generator for music, and there was a period where it was super annoying, but I kind of got used to it. Now I just don't realize it's there even. But that was the point.
What is the name of this one in particular?
It's here. It's on screen. Untitled 19. Okay, this is a very interesting issue. How could local to parent be uninitialized? Or actually, no, it is initialized. It's here. It has a very tiny transform attached. The parent. Parent also has a transform. The parent actually has. This transform is empty. Parent of the parent, the location. Location has no transform as well. Okay, the root widget has a transform. So this is the camera transform, scaling and position offset. The window has also its own transform. Yeah. Scaling and offset. We have a theory, maybe parent and children, they are not matching. So addresses, I need addresses. Parent widget has this address. Its parent is, I have no idea what it is. Say this is the parent. Yeah. It's somehow different address. This is 6E010 and this is 6C0F0. Totally different address. Maybe not. Oh, it looks good. Actually, no, this value looks good. Value looks good. Let me resume this. Has to be wrong. If I go up, yeah. There is a copy happening somewhere here. This child was this address, and when I change the frame to this one, maybe it's related to cloning. Cloning should create a proper object as well. Okay. When I'm here, I can print child is a power button. Yep. Okay, it points at a different object. Child parent. How is this possible? That should print some error messages. Should. I'm logging too much info now. There must be a difference in the way that fix parents iterates over the widget hierarchy. So it goes through each child. Recursive call for each child, makes sense. And the fill path. So there are some simple checks. For each child, a recursive call. Okay, this is the same child. Is it very different? Maybe I need to do dynamic cast or static cast somewhere. No, they are way too far away. Those are different objects. Okay, the first one makes sense. It's the first one, yeah.
Are you using a glib for Automat?
I'm using a rendering library called Skia. Skia.org. This one. It's a very good library. Hard to integrate though, so it's very fast, it has lots of capabilities, it's just hard to set up, and the API keeps evolving, so it tends to break every now and then.
Never heard of it. I typically use IMG.
Yeah. It's not very famous, but it is used by a lot of big software. It's the graphics library that powers like a lot of stuff. For instance, VS Code, right? VS Code is using Skia to render itself. Indirectly. But yeah. It's not using GTK or Qt or ImGUI. It's using Skia through Chrome. Chrome uses Skia.
Oh, interesting. Does it come with animation support, I assume?
It can output images, but it also gives you access to all sorts of synchronization primitives. So you can get a notification, for example, Vulkan semaphore, when rendering to texture is finished, and then you can composite the texture with your stuff. API is very nicely designed for Skia. It's not perfect, nothing is perfect, but I love it. It is very well thought out. So restart. Oh yeah, I remember.
This is strange. My tests are saying that the time is correct, but yet I can observe the behavior when pausing and unpausing my timer, that the time can go backwards as I mentioned before.
So we have two hotkeys in memory. Three actually. The third one is the deserialized one. I can put a breakpoint now. And okay. So it's C1, C0. Actually, no. I'm not interested in that. DFE0. Yes, DFE0. This is the correct parent. Yeah, I remember. I think I remember. The issue is because I was doing some silly trick that backfired. Hybrid adapter, exactly. So I created this fancy object that's meant to be a wrapper. All those widgets. Okay, let's, instead of returning widget name, I will return almost certainly the issue. So if current object is a widget, I'm creating this hybrid adapter. Yes, this is what was confusing me. Just a different object. Oh yeah, oh yeah. is to create a proper chain. This now wakes up properly. I can hover buttons and they highlight. Finally. I've done this to myself. So, from the mysteries, hotkeys are now properly hovered. Parrot is looking in the right direction and I think it keeps waking. That should work. So even if I don't do anything here, and I move my mouse over, it wakes up. So I think this is it. This is all bugs fixed. I have more cleanups to perform. I'm a little bit worried. We still have bugs, probably more than before. I will fix them in a moment. Time to commit this. Yeah, the big advantage of this widget management with unique pointer is that I can even embed widgets now into parent widgets, so they can be allocated in the single allocation. Not a big thing, but it's nice. Okay, so we'll switch back to this, but in a moment. First, I will do a short break. Okay, let's go.
Hi guys, I'm Raphael. Sorry, my voice has given up on day one and I'm just hanging on by a silver thread, but I hope we can still make this. Great talk.
Thanks.
Great work. I love the RAD debugger. Like, the times I've used it, I've been blown away by the power it has. Like, I think you sold yourself short in the talk by not just demoing all the cool stuff that the system, like, you talk about the system, but like the amount of power it gives you is amazing, and I want to dive into that. But like, first, after all the praise you've gotten for the RAD debugger and your skills over the past few days and before that, it was very refreshing to see you finally fail at a technical task, which is like wrestling with a shitty clipper. So that was really good.
I don't know what's happening. It's like buffering them up or something. You know.
Yeah, no, like, awesome. I'm hugely impressed with what you did with RAD debugger.
Thanks, man.
And since we know from old Twitter that you need about 1,000 developers to do like 140 character text posts,
Right.
How many tens of thousands of developers are working on the RAD debugger right now?
Right. So, you know, we really couldn't do it without at least 3 or 4. But no, I'm just kidding. It's just, so currently it's just me, and then there's another developer on the team, Nikita Smith, who's not here. He works.
Quite often, the fewer the better. There is optimal size of the team, which is just a couple of people.
Primarily on the rad.
More you add, there's even a book about this, the mythical man-month. So it's a fallacy to think that an organization with multiple thousands of people will be faster. It's doing a lot more work. It cannot develop as fast.
Linker, but you know, which is a part of the project for a number of reasons. But there's a lot of overlap between like those problems. Like a linker has to produce debug info, debuggers have to read it. There's a lot of shared. We both have to parse certain formats, stuff like that. So there's a lot of overlap, and so Nick kind of works on those parts of the problems. He's really good at like how do you unwind on Windows X6, like how do you unwind using PE unwind info on Windows x64 or whatever. It's like he's really good at that kind of thing. I've focused primarily on the debugger itself, the process control stuff, the UI, obviously, the visualization engine, the evaluation engine, like stuff like that. So us two, those are what we do.
All right. And yeah, in case people haven't heard it, like Casey yesterday called him the best systems architect he knows.
Oh my. I think I know what is going on.
Maybe he said one of, but if he said it
Very-
quietly. Like I heard
yeah.
best systems architect.
Very high praise. Yeah.
And you're like, you're
was honored.
super young. How do you get so good so fast?
With the timers.
Seems like even Casey said yesterday, like he had his oops phase where he did heavily object-oriented programming and did all the pitfalls. And I certainly had that time where I had to unlearn, like do all the damage that you do with that and then see that and unlearn it and just come back to the roots. Like, did you skip that phase or did you pass through it quickly, or how do you get to your skill level at your age? Like, what happened?
So, I mean, one of the reasons I got a pretty good head start on everyone, I started programming when I was like 6, and it wasn't my own doing. It was my older brother who showed me it, and I was like fascinated by it. I did have that phase, although I was too lazy to actually go and do all the complicated like template stuff that Casey actually did. So he actually tried much harder and like went much further in that direction than I ever remember myself doing. I definitely had it though, because it's what people tell you to do, right? Like you go and read tutorials and every code is structured in a particular way. And so you just kind of copy it. And,
Yeah, I am only accounting for up to seconds, but when I need to unpause a timer, when we're calculating the new time, I am missing out milliseconds. And so it could be adding that on each time.
Rounding issues.
thing.
The native time format on most CPUs is nanoseconds. This is how operating systems like to give you time the most. And also GPUs. GPUs also keep track of time in nanoseconds. At least this is what Vulkan mandates.
CP Chica says,
You need to be very precise when telling a computer what to do.
And I just figured it's important at some point, someday, to someone that I put everything behind a getter and setter or whatever. It's like, oh, this will be useful someday. Never was useful. But it's I just started doing it, but I didn't go nuts with like the crazy abstraction template stuff. I did a little bit of that, but not I didn't go far down that rabbit hole. The way I got out of it is just Handmade Hero. Like I was spending a lot of time building games and
Imversi says,
CP Chica, you do, but unfortunately we are human, and oversights happen.
The early 2000s, sort of like C++ 03, early before C++ 11, like that style of code where it's like object-oriented crap mixed with C, basically.
CP Chica says,
Invosi become robot Dorda.
And I thought that I believed in a lot of things that were kind of leading me astray, but I didn't actually try that hard on them because I was too lazy. Because it's just a ton of typing. Like Casey was like, when Casey was talking about it,
Imversi says,
Haha, then I'd be a professional liar.
and I'm like, I just don't want to do that. So I kind of stayed more constrained and just tried to build games that way. And then when I saw Handmade Hero, I'm like, oh, like none of that was needed. Like I didn't have to even have to like open the door to that hallway. I can just actually not get sidetracked.
So maybe a bit of laziness saved you.
Yes.
Okay, that's good.
Yes, it's my laziness saved me, I think.
Ever seen GPT try and play chess? Enough said.
Channel, I saw that like you described your like kind of the generic building blocks you assembled to visualize data in the debugger, and it seems like when I just watch like the thing.
I love this series where, chess players tried to play with GPT, but honestly, patiently tolerating all of its made-up moves. Okay, that works.
Things you didn't show, like all the things you demoed on Twitter, etc., of the power that gives you. It seems like you discovered the right building blocks that give you enormous expressiveness with very a small set of like it seems like a small set of Lego blocks, let's say, to assemble it.
Yep.
How do you do that without like? How did you arrive at that? Because a counterexample I would give of people trying that is like, at some point I think the Office suite decided that
CP Chica says,
Yeah, happens because it does not operate on real-time data, but rather on preset games and confabulates, moves that were played against certain moves.
I actually wonder, maybe it would play better if you, every round, if you repeated the current board state to the bot, or maybe even listed possible valid moves. Maybe then it would not make up as much. I changed the instruction library. Instruction library seems to work. Find action. Okay, I changed find action. So when I right click, this. Okay, so I was able to replace that.
be a draggable window, and of course a window that's floating should be closable, and so they came to this great state where people could just close their menu bar and be completely host unless they Google how to restore that. And like they tried to be very generic and have building blocks of like everything's a draggable window and we're gonna get a great power of that, and the result we all suffered. How did you get to this set of building blocks? Was it like, do you have to iterate on that? Was it trial and error? Was it undo, redo dozens of times, or are you like Neo and just see the?
I'm definitely not Neo. I think that where I've screwed up in the past, and where I think a lot of those designs are screwed up, is when they try to abstract over, like they have like one interface, but that interface actually implies many concrete realities, and I think people lie to themselves a little.
Say we played Ponciani, F-hour, F5, and F3, N6, C3, which is similar potion to some English London system, where queen goes A5. It thinks 75 GPT would hang a queen. They're wrong. Mike was muted.
Yeah, this is the cost of learning chess from books rather from playing, which is, I guess, what the GPT went through. Here. Oh, Ooh. New errors. Probably because of my fancy hybrid widget. Yeah, definitely. I knew it. I knew it. So those connections, they should disappear when I position widgets over the timeline. They do not.
And best move is really illogical when playing by the book. It's d5, allowing your knight to be pinned against king and risking losing both rooks and a queen.
Concrete details actually float up and are needed in the abstraction. And so those abstractions get pretty brittle and leaky. And so I think it's that root problem where it's like you've got one thing you want to treat as one thing, but it's secretly multiple things, and you don't want to pretend that it's multiple things. Now, the way that I tend to think about it is like I'm always trying to take a path that's doing some work. So in the case of the evaluation system, I started with just the debug evaluation. So I started with like, look, I've got an address space, I've got a selected thread that's inside of a debug. I can evaluate things inside of that. And what I at some point I thought hard about it, and I noticed that like this file system split was going to be a problem. And so I needed to find a way to take the existing code path and like kind of just widen it. Like you want to just say this is expressing more than what it was before. So it's actually the same concrete code path. It's not an abstraction over many things. It's just one thing, which can.
I'm listening to this, and I think I'm realizing what's with the object-oriented programming. So Casey likes to create this strawman of object-oriented programming, where object-oriented programming is about modeling reality as a set of objects instead of modeling your program as a set of objects that can be composed together. And like the stuff that Ryan did is like 100% object-oriented. You just provide this facade that he described. It's an interface. By all means, it's a piece of data with some functions attached to it that allows the same code to do the same solution to be applied to multiple kind of situations, as long as they satisfy the interface, the same interface. And I guess my theory is that they avoid the term object-oriented because of this strawman that they like to attack. And I actually wonder, are they going to connect for example, the architecture of this debugger with object-oriented principles? Because even when answering questions, they mentioned a couple of times that it's that they are against this dominant way of object-oriented programming.
Contains more information, and once you get to that point, it's like you could make the argument. It's
and the stuff that he's describing right now, literally about widening the path that the same code can solve. Yeah, it's about realizing that hey, a generic code can actually do more interesting things.
It's like, well, now the space is being specified when it doesn't need to be, or it's like just store the space, dude. Like it's not that much data. It's tiny. You're making it more flexible, basically. So I try to take that approach where it's like start by laying out my constraints, as many as I know, build a path which supports those, and then try to fit more constraints into it and sort of widen the possibility space as possible. It's super abstract. It's really hard to describe how I think about it, but hopefully that's some degree of insight into it.
So can you rephrase that as kind of like fat structs instead of
Right. Yes.
domain model statically,
Right.
whatever the thing was that I can't remember.
Right,
Like,
yeah.
so
We're Team Plex, basically.
Yeah.
So that's Plex. It's Plex programming, yeah.
for people who don't know what Plex is, watch yesterday's stream.
Yes.
You should watch it anyways. It's good.
Plex is one of historical names for objects.
Right, yeah, because I struggled, like, when I design systems, I don't have your skill, like, often, like, the building blocks don't quite fit, and they give me more complexity within that much power, and it seems like I would like to hit that sweet spot, as you did. Right, let's get more into, before I open to the, to the audience, I have a few more questions about the debugger itself. You didn't talk about the red debugger details very much, but you have your own debug info format.
Yes.
And you convert from code view, which is the Microsoft format that's stored in PDB,
Yep.
to that. What prompted that, and like how did you design that red debug info format? Like how is it different from Dwarf or code? That's very like into. I wrote the debugger myself. I generate debug info as part of the JI compilers. That this is what interests me. I'm sorry if it's not for everyone, but like how did you? What went into designing the red debug info format, and why is it better than PDB? Like why is it worth transforming?
Yeah, so the reason why that whole thing started, when I originally joined the project, the team was working on debug info parsing. Now, if you want to support a debugger that's like it's like a uniform debugger that works on both Windows and Linux. Like the original ambition of the project was Linux. Was a Linux debugger, a good Linux debugger. So we know we wanted to abstract over those two possibilities, and you kind of should, because it's just two different ways of exposing the same information from the underlying system in a sense. So it's like you should be able to. So we started, and of course on Windows and Linux they use two different tool chains. They use two different debug info formats. On Linux you have Dwarf, Windows you have PDB. We were building an abstract parsing library for it. And you can still find this code online, but it basically presents an interface, and it does that abstraction thing that I talked about, where it's like you have one interface and it applies to two concrete realities. So you've got a PDB parser as one backend, and you've got a Dwarf parser as the other backend, presented through the same interface. The problem is that when you're actually like wanting to use debug info, there's a lot of incremental things you want to do. You want to be able to say like, well, I don't want to parse like all the types if I'm just trying to take an address and turn it into a symbol. Like there's so much information.
Yeah, it has to be more granular.
It's like incremental parsing or incremental.
And this is hard. It's hard to express those intermediate states in interfaces. Either the interface has to be designed to capture this, or there is nothing else, or you have to write specialized functions for each one.
Lookups. It's kind of rare that you want just to parse literally everything right away. And so, long story short, because Dwarf and PDB are different in how they arrange that data, it gets like very complicated very quickly to build an abstract API that presents these incremental paths that don't have really weird details like, oh, in PDB, it's really fast to do this particular thing. In Dwarf, you need to do a parse all of that particular section before you can do this. And so it's just like a nightmare when you're actually writing stuff on top, because it's like every API now has two potential guarantees. It's like, okay, when I want to do this particular incremental parse, it might be fast, it might be slow, depending on what I'm actually using. And so I have very limited information about what's actually going to happen. And so what's much better is to just have, basically you do the parse all in as fast a way as possible, and then just use the full parse structure. But at that point, like it really just made sense to go the full way to the format. Like at that point, you're already doing this parse all, you have internal structures for it. What would be even better if like you could actually just serialize this to disk, have it be a much simpler debug info format that you can use everywhere. Because it's not just the debugger that has to use debug info. There's tons of tools that need to use debug info. And so we were like, we just don't want to work on PDB and Dwarf actually. Like it's actually terrible. So we just built this one, and in terms of like how you design it, like, I could give my thoughts on that, but the person responsible for the original design of the format is Alan Webster, who made 4Coder. So he has since, he's not on the project anymore, but that was like his last big contribution to it. He did an excellent job on it. And it's, I mean, it's kind of like how you do anything. It's sort of like what Casey was talking about. Like, get rid of the idea that you don't need someone omniscient about things. It's like, no, just like store the data with all the context that you have. And so the rad debug info format is like very simple. It's like, look, we've got these flat data tables and they index into each other. And it's just like the information you want laid out in a really simple way. And and that makes it very simple to do things like incremental lookups and like to use it much more quickly with all the guarantees you want, like from the debugger's point of view, for example. So instead of having to poke into 2 different backends, basically. So I may have missed part of the question in that, but hopefully that, yeah.
I'll do the follow-up later because
Okay.
it might be very specific. The rad debugger is it written in C or C+, or like?
It's just C. Yeah.
Okay, so bare C. Why bare C and not like often like many people actually in the talks right now picked bare C. I thought the common way was like to use C++, but almost nothing of C++, even as Casey usually does it.
Yep.
Like, what prompted you to do, nah, just pure C?
So I think like, so I don't tend to do very math-heavy code. So unsurprisingly, I mean, there's not a lot of like linear algebra in a debugger, basically. So it's like, I benefit less from a lot of things that people who need C++ do, which would be something like operator overloading. Like, that becomes pretty important if you're writing lots and lots of math code. For me, it's like I'm not writing that much code. I could build kind of the abstractions I wanted inside of C. I could build the tools I needed. And one of the most important things was that C compiles like 40% faster. Like, if you just have, and to explain how I know that, the code base used to be C++. It was Casey style C++, where it's like, you've got C++, it's mostly C, but then there's a couple of things that you use in there. And at some point, like, when I had like more control over the project, I was like, build times are important to me for the reasons I opened the talk with. And so I'm like, I'm just gonna like turn this to C because I'm pretty sure that'll compile faster. And it did. It's about 40% faster, at least on my machines. With whatever version of MSVC I'm using. With Clang, it's similar. And then and there's a couple of things in C that are actually better. Like Vyacheslav yesterday mentioned designated initializers.
This is false.
C++
C++ now has designated initializers.
does have them, but they're pretty bad. Like, they're not. Maybe they're fixing this. Somebody can tell me, but maybe
You have to enable C++ 20, and then they are there.
they're fixing this, but they have a very specific like ordering requirement on like the way you specify the initializers.
If it's initialized out of order, it will print a warning, but it will still work. It will initialize them still in order because this is still required.
Because of like constructor execution ordering or whatever, even if there are no constructors, which I don't understand that part. Maybe that's what they're fixing. But point being, in C you just have what you actually want, which is to say like this member, this member, this member in any order. I don't care. Like, just let me fill them out. So there's a couple of features like that I like a little bit more. It's mostly just like compile time. Also, I just like aesthetically, I suppose, prefer the idea of relying on a smaller tool chain to build everything. Because then it's like someday, like if there is a C compiler that comes out, it's like the debugger can be built with it. Whereas if I need some subset of a C++ compiler that happens to be a different subset than what everyone else needs, it's like, no, you're good. Then it's like that thing is never going to happen. Like, C++ compilers it's way harder problem than a C compiler. So it's like, I kind of just liked that option better. Seemed like a good investment.
And since you mentioned build speed, like rad debugger compiles really fast, even though like you have as far as I know, you haven't mentioned that in that talk, but you have a pre-processing step where you do code generation even.
Yes.
Like, do you want to get a bit into that? Like, what kind of, you do some kind of metaprogramming, as I understand, even in C, with your simple build system. Like, want to elaborate on that a bit, or have you like, is there a source you want to point to instead?
I can cover it pretty quick. I mean, it's just like, to do compile time execution in C, you don't need the compiler to do it for you. You just build a program, run the program, and then you build your main program. And then arbitrary compile time execution goes there. and yeah, so I mean, building C is really fast. So building the metaprogram, I do it every time. I build a metaprogram, I run it. And so that's basically how that works. What was the other part of the question? I think, was that just it?
Yeah, well, what do you use it for? Like, what do you do with the metaprogram and the code generation? Like, what do you use it for? Where is it useful?
Yeah, so I tend to, in the debugger, there's like, it's mostly a data management problem. Like, there's a lot of like, just giant things that you really want to be Excel tables that are like, just like, here's the information, like, here's all the UI commands, and here's like, how you, here's what they do if you trigger them with a hotkey and the command needs a little bit more information to execute. Here's what the query information looks like for that. Here's the name, here's the description, here's the icon, like all that stuff. There's like tons of like tables of all that information, and
Static data,
oftentimes you
assets.
want to use that to produce like a variety of C constructs. So it's not just like I want a struct for this. It's like, okay, I want a struct and a table of the offsets of the members and like a table of all the types and like things like that. Now you can do that with X macros to some degree, but I kind of don't like that because it's pretty opaque to simple tooling. Like my editor doesn't know how to understand X macros and all of that, and I'm not going to use an editor that can because all of them are really slow. And so it's like I'd rather just produce the C code I want. Now in other projects in the RAD debugger, I don't actually do this, but in other projects I do like more complicated metaprogramming where it's like I'm going to find like tweak variables that are scattered throughout the code base. I'm going to find all of them and build a data table so that like I can build a UI in my game, for example, that's like, here's all the tweak variables in the system, and you can just toggle them dynamically, even though the only thing I had to do to actually add that was say tweak and then like some value, and then it's like, there you go.
So this is partially how you avoid, like one of the drawbacks of using C and having to do a lot of macros to work around it is like, as we're on the topic of debugger, as anyone knows who's done that, debugging macros is a nightmare because you basically don't get the debug information, you can't properly step, etc., etc. So you also avoid that by generating the code instead of relying on macros. You kind of avoid that step and have code that you can step through. Is that a?
Yeah, that's one benefit for sure. That's partly a debug info problem. Like you could imagine debug info being slightly. In fact, I think Dwarf is. Like Dwarf toolchains tend to be more useful. I think. I mean, you tell me, but I'm pretty sure Dwarf is complicated because it's like, of course, it can express anything, but what compilers generate's another question, right?
Exactly.
But yeah, it's definitely partly that. I don't tend to do I don't use any like generics or anything. Like I do use like the like list macros that Vyacheslav showed. Like I have equivalents basically in this code base, and
you mentioned stealing them from you, I think. If where is he? Can we confirm? Yeah. Your code seems to be kind of the new standard library for C because I had it from a couple of people that they just steal stuff from.
I mean, that's fine, man. Like C standard library is pretty bad, so it's good to have like people just demonstrate. It's like you didn't have to stop with the standard library. Like you can actually build a good code base. Obviously, there's some runway.
Like Chambert has been the prime example of that.
Like, yep. Yeah. Definitely. Yeah. So.
I guess my final question before I open up is like. Gingerbill was kind enough to announce the macOS and Linux version of the RAD debugger yesterday. Are there any announcement you want to add to that?
Yeah, so I should clarify. Like, we haven't announced a Mac port or anything. Obviously, like, it's done actually.
The question is, when do you ship it? Like, it has been announced.
Yeah, I mean, obviously, we're focused on the Linux port next. So, obviously, a big early stage of so the debugger's in open alpha. I never mentioned that, but that's what it's in. So people can use it, and a large portion of work is just like making sure it works on large code bases, getting it more stable, like adding the features that people need, like stuff like that. Then the next phase is really the Linux port. So we're actually going to do the first porting step will be x64 Linux, and then we'll keep going in other directions. Like we'll be able to support ARM and like things like that. So that's sort of the direction. But like we're not going to be working on Mac and like before any of that. So while maybe he was just expressing wishful thinking. And once you've done the Linux port, my intuition is like you're not that far from a Mac port. Yeah. So I don't think it'll be like impossible. But yeah, it's just like we haven't like said that or anything.
Switch and iOS when?
Yeah, exactly. So.
All right. Any question? Yeah, please.
So you mentioned the idea of a black box at the beginning of the talk, and I feel like this talk goes a long way to kind of demystifying some of the inner workings of a debugger, which is very helpful, but I kind of wonder if there's ways to expose some of that to a user. One of the experiences that I often have with a debugger is I will point it at executable, I will start it up, and I say, I want to hit this breakpoint, and it's like, I don't know what that means. It's like, I don't know what file that refers to, or I don't know what like actual instruction that refers to.
Yeah.
And so there's all this inner working behind it to get that debug info, to find it automatically, to parse it. It's potentially, trying to match file paths. I might have like forward slashes, backslashes, whatever. There's like all of this inner tooling that can go wrong, and it kind of gets encapsulated in this black box that feels like magic, right? It's like, oh, I don't know anything about that as a user. So, is there anything you could do to make that better? You think?
Yeah, I think a lot of that is.
I think as a user, he means a programmer, like a user of a debugger. So he asks if it's possible to create like a library for a program to more closely talk with a debugger.
It's just like a UI design problem and like a
GDB has a protocol, and it's possible to write visualizers for, I think, LLDB. There is some mechanism for that, definitely. But I'm not sure what you can do with those protocols exactly.
Visualization problem. So it's like one thing that we do in the debugger, which like I don't think anybody does, but like what tends to happen if you put, like in Visual Studio, if you put a breakpoint on a line, if there's no line info, like that you're not running a program or something, it'll like just go to the line. Like there will be a breakpoint, shows up on the line, done. Then you like run the program and you'll notice your breakpoints like it snaps or whatever. And the reason why is because like not every line has source code, or sorry, not every source code line has actual code, which would be machine code instructions. And so like stuff like that can be like, it's really kind of interesting how it's like been accepted that it's like, that's just a way that it works. And everyone's like, oh, if it snaps, that means it found the line info. It's like, what? Like, what does that mean? So I think like, in the RAD debugger, I mean, obviously it's early, so a lot of it's not like done or documented or whatever, but I've tried to visualize a lot more information about what the debugger knows about than what other debuggers tend to do. So I've explicitly visualized, a lot of people ask about the colored gutters on the side of the source view. That's the line info. Also what happens is like, I don't reposition breakpoints. If you put a breakpoint on a line, I'll draw in it, and there's no code on that line, but there is some code on some subsequent line. General rule would be like, okay, let's make the code hit the next line with code. I just visualize that in the UI directly. And so I think it's a visualization problem and a UI problem. You're right that a lot of stuff can go wrong. A lot of that is not necessary, I think. Like the file paths, good example. It's like, not to blame anyone, because I've had bugs where I don't treat paths correctly, but it's like, backslash, forward slash, look, you can figure it out. Like the debugger should be able to figure it out. You know what I mean? Not the user. The user shouldn't have to care, but the debugger should be able to figure it out. So I guess that's what I would say. Like there's a lot of room for another spot of visualization, for example, would be like other debuggers don't tend to show where other threads are. Like it's just where the selected thread is for some reason. Like I just try to show all the threads that are in active view. So I don't know, there's lots of opportunities for visualizations and to just improve it basically. Yeah, I think that's the direction that you have to go for that. So.
So many questions.
What kind of cache eviction strategy are you using for the hash to data cache? Are you using like the least recently used?
Basically there's a few different sorts of reference counters in the system. One is if like that keying mechanism that I spoke about, where it's like you've got a key, it refers to a history of hashes. Every key that's touching a hash, that implies a reference count. And so if the reference count's ever non-zero, that hash is going to stay there. Now it only does that to some extent, so it'll start throwing away things that are old in history, but it'll keep like the two most recent states at the very least. But once you know that, and then the other ref count that's in the system is if someone's accessing the data, right? So it's like if I didn't get into the code really, but like if there's a construct called a scope to access these caches of like large data, and so the API construct is basically you obtain a scope, you grab the data, and then you close the scope. And then while this scope is open, you're able to talk about that data. You're able to read it. And if that's happening, obviously you can't evict it. So there's 2 ref counts like that, where it's like, if a key is referring to this, you keep it around. If a scope is opening it, you keep it around. If neither of those things are true, then it's kind of just a heuristic of like, well, you know, it's not false that this hash maps to this data. Like, we could keep it around forever. But, you know, it's kind of a heuristic of like, well, you know, do you want to throw it away? Like, and you can throw it away, like, if it's not accessed in 10 seconds, like there's some caches like that, like texture handles, I'm like, if nobody's accessed it in 10 seconds or whatever, I'll just throw it away, basically. And it's not least recently used, basically, because I'm just like, I mean, I could do it that way, but I'm kind of like really brute forcey about it, and it just doesn't matter. It's just like, look, man, loop over the textures and throw away the ones that, you know what I mean? Like, that's kind of how that works. Yep.
Have you run into issues where like, because all the visualizations you have and the data, like, is it like, oh my God, like how much memory does it, like, is there like, are you forced to be aggressively evicting stuff to kind of not blow up everything, or is it pretty chill? Like, I have no feeling for the amount of data.
Really depends on what you're visualizing. So like, early when I prototyped the bitmap viewer, I had like a video playback, like I was going through a Bink program sample that like plays back a video. And on each frame of the video, I would visualize a new bitmap. So I could hold F5 and watch the video in the watch window, which was pretty cool. But you know, if you don't have a good eviction strategy, you like you open up Task Manager or whatever, you go look at it and it's like, ooh, yep, exactly. So over time, it can grow pretty substantially. So I tend to evict them, like I said, it's like different heuristics. I don't remember exactly what the numbers are, but I'm like, if nobody's touching this in a long time, throw it away.
It would be cool if there was an operating system level evictable memory. I mean, you allocate a block of memory and you use it, and when the OS wants, it can kind of take it away, but in a safe way, so that the application can access this block, kind of lock it periodically, and make a weak reference to a block of memory that the operating system can take away. That would be interesting, especially for large things like bitmaps. That would be nice to have.
Away. And that tends to just kind of like soften that problem, basically.
Yeah.
So talking about visualization, have you considered also visualizing things dynamically over time, like how the changes of things have also, I realize what I'm saying. I'm wondering, like, for example, for bitmaps, like you can highlight, like as in render doc, okay, here's where the change happened from the last time you looked at this thing.
Yeah. So so I haven't done it in every visualizer. So a lot of what I talked about today was like the visualizer architecture, like sort of like how the building blocks are all arranged. But I haven't actually most of my work has been on that part of the problem to make sure that's solid before I go and build like fanciest bitmap visualizer known to man sort of thing, which like, if, you know, but so I don't have that particular feature in the bitmap visualizer, but like the memory viewer, I do, like, is an example where I do have that feature where it's like you show the changes as they happen. Now, obviously what you want is kind of what I alluded to at the end of the talk, where it's like you really want to scrub, like you want a timeline, like Whitebox, where you want like, you want a timeline where it's like, look, I've got this whole history of those hashes where it's like, there's more information you need, but it's like you've got this history of data transforms applying to this. And really what you want to do is just like rewind to those states and see like what the data was actually like then. And you know, I haven't done that yet because it's like subtle with how you want to do that. Like, how is that related to time travel debugging? How is it, like, there's a lot of questions that I would have to answer to actually like tell you how that system works fully. But yes, that, to answer your question, like I've done like in the watch window memory view, I show as things change. I don't have like the super fancy timeline scrubber yet, but it's like, that's kind of, but yeah, for sure. You definitely want that.
Yeah, for people at home, like Andrew from White Box is here as well, and
Yes.
some people have been aggressively pitching like a debugger cinematic universe where like White Box, Blood Red Debugger,
It's the Avengers.
yeah, the super team of like debug Avengers. Yeah. Yeah, please.
When you get the information from the operating system about the debugger, the memory, do you get memory ranges? Do you get allocation? Do you get individual pages? If there's allocations that have been made that haven't been given pages yet, is that information you can access?
So you can obtain information like that, but the debug events don't actually contain that information. You don't get the debug events don't report anything, at least on Windows. You don't get information about like this range was reserved, for example. What tends to happen, like all the stuff that the debugger currently uses is like read process memory, like it calls just that API, so it can read any range, and it can infer from how that API returns like whether it failed for some pages. So we can infer stuff like that. Now, even if there's no way to actually know, like and I haven't used it, so I don't fully know, but I'm pretty sure there's Windows APIs to like actually get more information about the page table, basically. But even if you didn't have that, what the debugger could do is actually just hook all those APIs and build it up for itself. So if like you put it int3 in virtual alloc, for example, and then decode the arguments, you could start actually building up like, oh, here's who's actually reserved or committed what. That's more complicated. I'm sure there's probably some APIs to actually just visualize it, to get that information directly. But yeah, that's kind of the degree of my understanding about it. But yeah, we don't get that as like a mainline thing when you just hook on as a debugger. But yeah. Yep.
All right, Nuno.
So one of those pain frustration points with debuggers, and specifically like if you're talking about big projects like Unreal, and it kind of becomes like logging, is that you run across that issue that your engine is optimized, so you don't have information, and then your game is not optimized, and something happens that is very hard to track, to replicate, whatever. Then you get to that point that you need to inspect stuff. It's like, oh, there's nothing here. Oh, also nothing here. And you just go to a point that's like, okay, now I have to go back, make things not be optimized, maybe in this file or this module or whatever. And I think there's something, some project or something from Microsoft or something recently, where they kind of grab the two builds and then you can kind of, okay, try to get the information from the other one. Are you planning on doing something like this? Or?
Yeah, so that feature in particular, there's a lot of ways that you can approach that problem. One is with like hot reloading, for example, like if you want to not actually have to recreate the state, for example. But yeah, that particular Microsoft feature, to my understanding, I haven't actually dissected it fully, but my understanding is basically like, yeah, they do the build twice. They take the unoptimized version and the optimized version. They're the same binary. And there's some mechanism by which the debugger can programmatically control which is which for any, I assume, symbol. So I'm not 100% sure on how it's sliced, but that's kind of how it works. Now, the utility of that's questionable because it's like you're building the thing twice, and the binaries are twice as big, and in many cases, the binaries are...
Strange to me. I always thought that optimized builds can have debug symbols. It's just they are not very accurate, because optimizations mix different pieces of code together, or sometimes split the same code into multiple places. But this is the job of the compiler, to keep track of this mixing and still provide some information out. At least in ELF, this is the case. You can compile with all optimizations and still have debug symbols enabled. They will be garbage, but they will be there.
Close to binary size limits anyways, so I'm not actually sure, like, you know, I mean, if it works, that's great, obviously. But yeah, if that feature would not be hard to support for the debugger, because basically what you need to do is just have the debugger, whatever state it needs to change to switch from optimized to unoptimized, it's all in the binary, it's all code the debugger can refer to. So all it has to do is change that state. And, you know, it seems like it'd be a pretty minor reverse engineering task to actually find out what you need to do for that. If they tell you nothing, which they might tell you more than that. So yeah, hopefully that answers the question.
Yeah.
So I think this is also kind of what you're planning with Workbench back in the background, but now that you're blurring the lines between like the debuggy inspection and inspecting files, to what degree are you planning to kind of look? I might open up a hex editor to look at the file, but if RadDBG is like a really awesome hex editor and I can just drag a file into it, right?
Yep. You already can.
Yeah, exactly. So think about that, and then a lot of people obviously ask, okay, this is awesome, but could I edit my text in RadDBG, right? You know,
Yeah.
do you have plans to kind of go down that road more with RadDBG, or is that more of a long-term, different project?
Yeah, I think so. Obviously, there are higher priorities than making it a text editor, but I think like it's definitely clear that you want the ability to mutate data as well. So it's not just about viewing. Like the visualizers aren't just for viewing; they're for writing. So a hex editor's a good example. Like when you're viewing the grid of bytes, it sucks if you can't actually like in the rad debugger you can't currently mutate the bytes, but you really want to. And so similarly with images, like if you can like change the values. In the watch window, it's the same thing. You can edit values. So I think that should all be possible. So the text viewer really should become the text editor at the limit, I think. I'm not going to prioritize it because there's a lot of other things to happen first. But I think like, yeah, I think someday that'll fall in there, even if like, you know, there's a lot of good arguments against having a text editor like as a mainline thing that's always on in a debugger. But so maybe it's, you know, maybe there's still a mode switch where all your text becomes read-only when you're not editing it, or when you're debugging it, rather. So you don't, like, add a new line and all your debug info is broken or whatever. It's like that stupid problem. But yeah, I think at the limit, it turns into that. It really does.
Yeah. So just to add on to that, actually, I thought one really good argument for doing this is that all these type views, like for example, the view rules and stuff like that, that looks a lot like, so for example, 101 editor templates that they use for inspecting files.
Yep.
So if you could have like a description of a binary type that's like, this is my type, and you could look at it in memory in a debugger, but you could also look at it in a file, I think that'd be really awesome.
Yes, yeah, for sure. Agreed. Yep.
Like if you keep adding like editing features to the visualizers, you're gonna run into antitrust issues sooner or later because like, oh no, I'm not only eating all the buggers, I'm also eating the paint programs and the hex editors.
Right.
And like, yeah. It is Red OS. It's just renamed improperly.
Yeah.
So my question is, how do you annotate the types? Say that you have a project with a lot of textures, but you know that your own type. Like, can you save it on a project basis so that you can always like look at your pictures, or do you have to always like enter it when you start having the debugging session?
Right. So for some reason, you know, you asked that question, and I thought I had a slide about it. Maybe I just had a sentence on my notes that I forgot to say. But even though I realized I was reading, but yeah, I guess I forgot to say it, or maybe I misremembered making a slide for it. But point being, yes, there is a way to annotate that types should be expanded in some particular way. And the way that works basically is because, so what you would enter manually when you start a debugging session is like, say you've got your texture type, and it's like a loaded bitmap type, because it's all CPU memory, obviously. You need to do other stuff for GPU memory, but let's say you've got a loaded bitmap or decoded bitmap type or something like that. You have an evaluation of it. In order to start visualizing it as a bitmap, you would say, okay, call the bitmap visualizer with like, you know, your loaded or decoded bitmap dot data, and then maybe decoded bitmap dot width, and then dot height. And so the mechanism I have in the RAD debugger to support that associated with type info is just the visualizers to the user facing thing. I call them lenses in the code, but to the users they're just called views. And the feature in the RAD debugger is called a type view. And the type view is just basically saying, here's a type expression. And if you evaluate something as this type, I want you to actually evaluate this expression instead. And because each expression can include the visualizer selection and parameterizations, you can say, okay, I've got this decoded bitmap type. Oh yeah, and the second part of it, this expression can refer to the original expression. So basically you say, decoded bitmap is my type, and the way I want to visualize that is bitmap, and then you can even just refer to the members by name. So you can say data, width, height, close paren, and then that can either be saved in your program. We have a header library where you just like say write img type view, decode a bitmap base width height, or it can be in the debugger config. And then either way, when the debugger loads the program, it'll see that type view and it will apply it to all evaluations of that type. So then even if you like hover it in your source code, you'll see the bitmap.
And it's a nice example of how you think about the whole pipeline of like, the idea is to reduce the total round trip time. So if I have to re-enter my expressions every time, that sucks. How do I remove that? And you came up with that header, including the header and having that special visualizer type info in the program so that it's there when you run it.
Yep, and it's the same thing as NatVis as well. Like it's sort of the extension and cleaned up version of NatVis.
Yeah, like LVM, like LDB, etc. Other debuggers have that, but it's not in your program. Like
it's a big problem.
It's always a sidecar thing. Yeah.
Yep.
All right. Any more questions? There were more hands. Guess they got tired. Yeah.
This was sort of a follow-up to the file visualizer kind of question, but did you ever consider dumping the data to file in an efficient manner so you can use existing programs?
I mean, it's sort of like the problem once you're stretching across the program boundary is that the operating system primitives that are available for program integration are kind of too weak for what you really need. And this is why people want integrated development environments at all. It's because their text editor and debugger and like all these other things they want in their IDE, they're really like, they could be separate programs in principle, but it seems like the tools that the operating system provides for these programs to connect with each other, they seem a little bit too weak, rich enough to really provide what people want. And so people want an IDE for it. It's pretty much the same thing here. It's like once you dump stuff to files, it's sort of like you've introduced a cache eviction problem. It's like, do we just leave those files there forever? How do we open the other program? Is it different for every program? Like how I've got to start calling these other programs in this way. They don't live update with the debugger. Like, what do I have to re-serialize to disk? And then it's like the other program has a pop-up. It's like the contents of this file have changed, and it's like, dude, like this sucks. Like so in a better world, an operating system maybe would make this all work. I don't think they do right now, and so I just built it this way.
On the flip side, do you consider having developers create plugins or like new panels or visualizers or whatever?
Yes. So I think I also had notes that I just didn't say about that, but yeah, basically what you want is the ability to say like both. There's an argument to say like you want to write a plugin for the debugger itself, like a DLL or something, or like some kind of a script where it's like I just want to put this visualizer code into the debugger as an extra one in addition to the built-in ones. Or an even better option in many cases is like that stuff should be in the program, like next to the type info. So there's a limited version of that with the type views because you can sort of say like the expression is programmatic really. So it's like it is. I don't think it's Turing complete because the bytecode can't jump backwards, but point being it's like a little mini program. And so you can do a little bit of that with the type views, but really at the limit what you'd want and what I hope to eventually support is like, no, like here's my struct and it's like a complicated entity or a node or whatever. It's like, and here's the debug visualizer path, like underneath it. And then the debugger should just be able to call that and then fill out a tab. So that's what I want to do. Yeah.
All right, I think we're out of time. So thank you, Ryan, again. Thank you very much. Give it up for Ryan once more.
Thanks, everyone.
Again.
Thanks, man. Appreciate it.
That was a nice presentation, and the debugger is definitely implemented nicely. I mean, I was actually betting that there would be a question about object-oriented programming, which it's so weird because on one hand, it seems like it's a target of many complaints, but on the other hand, it's also the foundation of this debugger, right? And on the other hand, it's also sorts of amazement and wonder that how it's possible that, you can create something that works generically with different data types underneath. I was disappointed that there was no such question, actually, because I'm actually wondering what is the reason? Okay, I fixed almost all of the issues. I introduced a new one, but it's kind of getting late. We finished watching what we wanted to watch, so I guess we will put a stop here. So yeah, we're going to see each other on Wednesday, and I have to cut the devlog now, so see you in 2 days. Bye bye.